All right, hello and welcome back to another episode of Ether Cosmology. Tonight is going to be the second episode of our what are we titling this, Toby? The reading roundtable? Is that what it?
I've just been calling it reading night, I think.
All right, yeah, the reading roundtable. So we're going to be continuing on with the Galev saga. We're going to be examining his later work in 2002, measuring the ether drift velocity and the kinematic, and the kinematic ether viscosity within the optical wavebands. So we're gonna get into this, and let me open up my copy here, and I'll just follow along with you there. Then whenever you want me to take over and read, just tag me in, bro.
Cool. Sounds good.
All right.
Pardon me. So, yeah, the experimental hypothesis verification of the ether existence in nature, i.e., the material medium responsible for electromagnetic waves propagation, has been performed. The optical measuring method of the ether movement velocity and the ether kinematic viscosity has been proposed and realized. The results of systematic measurements do not contradict the original hypothesis statements and can be considered as experimental imagination confirmation of the ether existence in nature as the material medium. The experimental hypothesis verification of the ether existence in nature, i.e., material medium, responsible for electromagnetic waves propagation, has been performed earlier in the works 1 through 3 within millimeter radio waves band by the phase method. The results of the experiment 1 through 3 do not contradict the original hypothesis statements based on the ether model of V.A. Edotovsky. In the model 4 through 6, the ether is introduced by the material medium composed of separate particles that fills in the world space and has the properties of viscous and coercible gas. It is the construction material for all material formations. The physical fields represent the ether various movement forms, i.e., the ether is the material medium responsible for electromagnetic waves propagation. The experimental model of basis 4 through 6, first of all, the positive results of the ether drift search published by D.C. Miller in 1922 to 1926 and A.A. Michelson, F.G. Peace, and F. Pearson in 1929. The experiment 7 through 9 is performed within the electromagnetic waves optical band, differed by careful preparation, verified methods of the investigation conducting and statistically significant measurement results. The measured ether drift parameters mismatched to the ether imaginations available at that time. As stationary medium, orbital component of the ether drift velocity stipulated by the Earth movement around the Sun with a velocity of 30 kilometers per second was not detected. Miller obtained that the ether drift velocity at the height of 265 meters above sea level in Cleveland, United States, has a value of about 3 kilometers per second, and at the height of 1830 meters, Mount Wilson Observatory in California, about 10 kilometers per second. The apex coordinates, the solar system movement, were determined. The direct ascension of alpha around 17.5 per hour, declination of this is gamma, right? God, I gotta pull my epsilon about plus 65 degrees. Let me pull up my Greek thing so I don't get tripped up on that again. My Greek reference because
Also,
I'm
can you post
still
the Greek thing in chat again? I forgot to save
yeah
save it so I could do the same.
yeah. Where is it here? Let me
Yo, what
bear
up,
with us,
Stone?
listeners,
Yeah.
and also to listeners, real quick. Hopefully the stream stays up. I've had a lot of problems recently. I made a bunch of changes on my computer, hoping I found a problem, but not totally sure until give it a shot. So I apologize if you get disconnected, and also welcome Stone and whoever else is here.
Riggs and monophone or
Awesome.
phono mono or something like that.
Where did I save that?
I'm just chilling. You guys make things go easy.
I'm just gonna find a new one.
All right, no worries. We'll just continue reading.
I
Let's
love
see.
hearing you guys just pimp slap, honestly.
Nice.
Here we go.
It's the best.
Free printable. Yay.
Nice. Thank you, sir.
All right. So that was. That's not theta. Isn't that theta?
Oh, I'm sorry. It's delta. Delta
It's delta.
approximately equal to 60 plus 65 degrees. Is
The
that what you're talking
delta.
about?
Yeah. Okay.
Yeah.
Yes.
Yeah,
Yes.
sorry about that.
All right. Declination of delta equal to approximately plus 65 degrees. Such movement is almost perpendicular to an ecliptic plane. Coordinates of the North Pole ecliptic, alpha of approximately 18 per hour, and delta of approximately plus 66 degrees. Miller showed that the observed effects can be explained if to accept that the ether stream has a galactic space origin and the velocity more than 200 kilometers per second. Almost perpendicularly directional orbital component of the velocity is lost on this background. Miller referred the velocity decrease of the ether drift from 200 kilometers per second up to 10 kilometers per second to unknown reasons. Some peculiarities of the experiment results, 7 through 9, and
Pause for a
10.
second. So
Yep.
yeah, so like that just they go in. So there's all these different velocities that they expect, right? Because Earth's moving around the sun, it's moving with respect to the center of this Milky Way galaxy, which is also moving with respect to the cosmic microwave background, so on and so forth, right? So there's all these planes of motion that the Earth should be intersecting with during its rotation or yearly motion, etc. Around the sun and whatnot. So there's going to be different vectors of force coming, or I'm sorry, different vectors of ether wind coming in, and so the only reading they get, the highest reading that they've got at altitude, under best conditions, which was trial and error figured out by Miller, is 10 kilometers a second. That's the best proportional velocity relationship that they can get before they start adding in corrections, changing how they're counting the fringes, etc. So it's like, this is attributed to unknown reasons. Like there's no mechanism for it. It's just kind of like, hey, let's this is what we got, this is what we expect. Let's just move on and fill in the gaps later.
Gotcha. Thank you. Yeah. That's why we're going to do soon here a presentation about first versus second order, and so we can kind of get into the details of how the first order stuff is not so easy for them to explain.
Yep.
So some peculiarities of the experiment results 7 through 9 and 10 are explained by the ether viscosity in the works. In this case, the boundary layer in which the ether movement velocity, the ether drift, increases with the height growth above the Earth's surface, is formed at the relative movement of the solar system and the ether near the Earth's surface. In the works 1 through 3, it is shown that the results of systematic experimental investigations within radio waves band can be explained by the wave propagation phenomena in the moving medium of a space origin with a vertical velocity gradient in this medium stream near the Earth's surface. The gradient layer availability can be explained by this medium viscosity, i.e., the feature proper to the material media, the media composed of separate particles. The mean value of the measured maximal gradients was equal to 8.6 meters per second per meter, or times meter. The velocity comparison of
It's 8.6 meters per second meter.
per second meter. So what would they mean by
just like
that?
you would say kilowatt hour. You know what I mean? For every
Okay.
second that you go, for every meter that you go.
Gotcha.
It's 8.6 gradient.
Thank you. The velocity comparison of the suspected ether drift measured in the experiments 1 through 3, 7 through 9, and 10 is performed in the works 1 through 3. The place distinctions of geographic latitudes and their heights above sea level are taken into account in these experiments and conducting at the comparison. It is obtained that in the experiment 1 through 3, the ether drift velocity is within 6,124 through 8,490 meters per second, so 6.1 to 8.5-ish kilometers per second. That according to the value order coincide with the data of the works 7 through 9 and 10, which are within 6,000 to 10,000 meters per second. The comparison result can be considered as mutual truthfulness confirmation of the experiments 1 through 3, 7 through 9, and 10. The positive results of 3 experiments, 1 through 3, 7 through 9, 10, give the basis to consider the effect the effects detected in these experiments as medium movement developments responsible for electromagnetic waves propagation. Such medium was called as the ether at the times of Maxwell, Michelson, and earlier. The conclusion was made in the works 1 through 3 that the measurement results within millimeter radio waves band can be considered as the experimental hypothesis confirmation of the material medium existence in nature, such as the ether. Further discussions of the experimental results 1 through 3 have shown the expediency of additional experimental analysis of the ether drift problem in an optical wave band. Experiments 7 through 9 and 10 are performed with optical interferometers manufactured according to the cruciform Michelson schema 12 and 13. The work of such interferometer based on the light passing let me reread this. The work of such interferometer based on the light passing in a forward direction and returning it to the observing point along the same path. The Michelson's interferometer sensitivity was low to the original ether drift effects. The measured value D in such a device, i.e., visually observed bands offset in an interference pattern, expressed in terms of a visible wave or in terms of a visible bandwidth, is proportional to velocity ratio quadrat of the ether drift W to the light velocity C, the optical length of the light beam L, and is inversely proportional to the wavelength of the electromagnetic emission of the light. That's lambda, right? Or is that delta?
Lambda.
It is lambda, yeah.
Lambda. And let me actually throw a couple more highlights on here real quick.
Yeah, so while you're highlighting that, so what he's describing here with the math and everything in this proportional squared inverse relationship is how interferometry you can analyze the fringes to get a proportional velocity relationship. So this is how inertial navigation systems work. This is how, what else do they use for that? Any motion-based interferometry, any detection of motion, you're going to be doing it with this, and you're going to be counting the fringes, and that's going to get you your inversely proportional relationship to the type of wavelength that was emitted as well, ratioed against the speed of light, and that will give you the velocity.
Excellent. So D, which is the measured value in such a device, equals L L divided by lambda times W divided by C squared. We shall call the interval which a beam passes in the interferometer measuring part as the optical length of the light beam. The research methods and experiments in the investigations of the ether drift, in which the measured value is proportional, W divided by C squared, was called as the methods and experiments of the second order. Accordingly, the methods and experiments in which the measured value is proportional to the first ratio extent W divided by C are called as the methods and experiments of the first order. The ratio is W divided by C is much less than 1 at the expected value. In the experiments of Michelson, Miller, W is, in the expected experiments of Michelson, Miller, W approximately 30 kilometers per second. The methods of the second order are ineffective at this requirement. So, at W approximately 30 kilometers per second, the method of the second order in 10,000 times succumbs on sensitivity to the method of the first order. However, at that time, the methods of the first order suitable for ether drift velocity measuring were not known. Let me go ahead and actually grab that highlight as well.
Yeah, so what he's talking about here with this C squared and just ratioing it against C without squaring it is what is that, like a directly proportional, well, as he said, like it's a directly proportional ratio against the so-called speed of light, right? So there's no, like there's two velocity components in this proportional relationship, and one would be the ether wind, and then the other would be the speed of light.
Excellent, thank you. So the expression 1 allows us to estimate the difficulties with which the explorers of the ether drift confronted in the first attempts while observing the effects of the second order. So, in the widely known first experiment of Michelson in 1881, at the suspected velocity value of the ether drift, W approximately 30 kilometers per second, with the interferometer having parameters lambda is approximately 6 times 10 to the negative 7 meters, L is approximately 2.4 meters. It was expected to observe the value D is approximately 0.04 of the band, and it is in the requirements of considerable band shivering of an interference pattern. It is in the requirements of considerable band shivering of an interference pattern.
So that D approximately 0.04 is their expected fringe displacement, so that they could get their proportional velocity relationship to against C, so that they can confirm that the Earth is orbiting around the Sun at 30 kilometers a second.
Michelson marked the band were very indistinct, and they were difficult for measuring in customary conditions. The device was so sensitive that even the steps on the sidewalk and 100 meters from the observatory caused the complete band's vanishing. Later, in 1887, Michelson, also in his world-known work, together with E.V. Morley, once again marked the essential deficiencies in the first experiment as for ether drift. In the first experiment, one of the basic considered difficulties consisted in the apparatus rotating without the distorting depositing the second in its exclusive sensitivity to vibrations. The last was so great that it was impossible to see interference bands, except short intervals at business time in the city, even at 2 a.m. at last. It was marked earlier, the value, which should be measured, i.e., the interference bands offset because of something on the interval smaller than 1 divided by 20 of the or 1/20th of the interval time between them is too small to determine it, moreover, at laying inaccuracies of the experiment. In Miller's interferometer for sensitivity increase, the optical path length in each of shoulders reached up to 64 meters. It was gained due to applying multiple reflection. The actual length of shoulders was reduced up to 4 meters. In experiment 10, the optical length of the path reached 26 meters. In the experiments 7 through 9 and 10, the interferometers laid on rafts placed in tanks with quicksilver that allowed to remove the influence of exterior mechanical clutters. Do you want to take over for a minute, Alan?
Yeah. The positive results of Miller's experiment, by virtue of their general physical significance, attracted the physicist great attention at the time. In the monographs, citation 15, 150 devoted to the ether drift problems, and referring to the 1921 through 1930, are mentioned that almost everyone were concentrated on this discussion with Miller's results. The possible influencing of the difficult considered the exterior reasons, temperature, pressure, solar radiation, airstreams, etc., on the optical circiform or cruciform interferometer sensitive to them, which had considerable overall dimensions in Miller's experiment, was discussed most widely in these works. Besides the virtue of the methodological limitation being in the works 7 through 9 and 10, their author did not manage to show experimentally correctly that the movement detected in their experiments can be explained by Earth's relative movement in the medium of the material origin responsible for electromagnetic propagation in citation 1 through 3. However, the most essential reason which made Miller's contemporaries consider his experiments erratic was the numerous consequent works, for example, such as 17 through 20, or citation 17 through 20, Miller's work were not confirmed. In the experiment 17 through 20, the so-called zero results were obtained, i.e. the ether drift was not detected, thus taking into consideration the deficiencies of citation 7 through 9 and 10. A major In a major number of experiments with zero results are available, it is possible to understand the physicist's mistrust in the works of Miller's work in citations 7, 9, and 10 at the time, the results of which pointed to the necessity of the fundamental physical concepts of variation. The analytical review of the most significant experiments performed with the purpose of the ether drift search is explained in the works 1 through 3 and citation 21. In 1933, Dayton Miller, in his summary, citation 22, performed a comparative analysis of multiple unsuccessful attempts of his followers to detect the ether drift experimentally. He paid attention that all in such attempts, except experiment number 10, which is the one that he did, Miller, the optical interferometer was placed in a hermetic metallic chamber. The authors of these experiments tried to argue that the devices, guard the devices from exposure with such a chamber. In the experiment, citation 10, the interferometer was placed in a fundamental building with an optical optical workshop at Mount Wilson, observatory for stabilizing the interferometer and temperature schedule. The hermetic metallic chamber was not applied, and the ether drift was detected. Its velocity had a value of W of approximately 6,000 meters per second. Miller made this conclusion: massive non-transparent shields available are undesirable when exploring the problem of ether capturing. The experiment should be made such in a way that there are no shields between the free ether and light in the way of the interferometer. Later, new opportunities for conducting experiments of the ether drift discovery have appeared also after the instruments occurred based on completely diverse ideas: resonators, masers, Masbauer effect, etc. Such experiments were held in citations 23 through 26. Can you highlight 23 and 26, please, too? Thank you. And again, the massive metallic chambers using a common instrumental error of these experiments. In the works of 23, 24, and 26, there were made metallic resonators, and in the works of 25, a lead chamber because it is necessary to use gamma radiation. So let's see. I wonder if 25's pound rep. Yeah, maybe not. Anyway, the
You want me to check real quick?
I do kind of want to know. It's eating away at me. It's eating away at
We
me.
can see what these are.
Yeah.
So we have
I've never heard of this.
Yeah, Essen. I'm not familiar with that. 955 Essen.
Oh, that's
But
Louis.
it's
That's Louis Essen. That's the guy that made the atomic clock.
Okay, so that's presumably. I mean, these are presumably all null results.
Yeah, and
Part
then
of the 30, the quote unquote 30 null results, right?
yeah, I've heard of the Jaska guy too, Jaska. So okay, cool. So these are okay. We'll come back to these later. These are just other interferometries placed in hermetic chambers and such.
Yep.
Okay.
Gosh, even with these, it's worth looking because they mentioned.
Oh, they didn't get like actual like nulls like this Jason guy. I can't remember off the top of my head, but he got not a null, right? And then Louis Essen, didn't get a null either. So yeah, we'll come
Well, it's
back
like
and
even
look
with
at
the
those.
2017 when they did with those chambers, they didn't get a null, because they washed it out with the statistical analysis.
Yeah, the old statistical and ally. All right.
Trying to detect daily fluctuations and seasonal variance, but you gotta make sure you account for daily fluctuation and seasonal variance before you can do that.
Yep. Oh, you were at the right spot earlier. You had it.
Yeah.
It was search gamma ray or gamma radiation. I'll take you right to it. Yep. Okay. Let's see here. So the authors of these works perhaps didn't pay attention to Miller's conclusions of 1933 about the bulk shield's incompatibility in the ether drift experiments. The physical interpretation of the essential ether drift velocity reduction metallic shields available was given by Vladimir Atsitovsky for the first time, having explained major ether dynamical resistance or metal resistance of Fermi surfaces available in them. So, what were Fermi surfaces? It was dielectric insulators and metals, all metals, to varying degrees.
Yep.
Yeah. So when you shield your laser beam and dielectric insulators, so things that are going to store electric charge or things that are going to conduct the flow of electric charge, the ether wind has a really hard time moving through those and changing that velocity of light. So altering those fringe patterns. So so what he's trying to say here is like think of the ether as like a stream going at a constant rate, and then they're just kind of blocking it, so they're not being able to measure that full effect. And because they're measuring a reduced effect, they're going, oh look, there's no stream, right? That's essentially what they're doing. So the importance of this right here, these Fermi surfaces and dielectric insulators and metals will become extremely important moving on throughout this paper, because this is going to show like a cause and effect relationship when he swaps out different metals and materials and gets different readings, and the mathematics that he uses to analyze it will also come into play because earlier his analysis was that the ether is a viscous gas material that's not interconnected as a one single unit. It's acting as like a particle, like a really fine small particle. So we're gonna as we read through here, we're going to understand why he came to this conclusion, and why these measurements that he's taking, like the ether is behaving like a viscous gas and a fluid.
Cool. You want me to take back over reading for a second?
Yeah, absolutely.
Cool. So we were. Are we here?
Yeah, right about there.
Cool. The purpose of the work is the experimental hypothesis test of the ether existence in nature within an optical electromagnetic waves band, material medium responsible for electromagnetic waves propagation. It is necessary to solve the following problems for reaching this purpose. To take into account the deficiencies that occurred in the experiments as earlier conducted, to elaborate and apply an optical measuring method and the metering device, which does not iterate the Michelson schema, but brings its analog to the sense of result interpretation. Michelson's interferometer of the second order is a bit sensitive to the ether streams and too sensitive to exposures. To execute systematic measurements in the epoch of the year corresponding to the epoch of the experiment's implementation 1 through 3, 7 through 9, and 10, the term epoch is borrowed from astronomy, in which the observation of different years performed in the months of the same name refer to the observations of one epoch. The results of the systematic measurements should be compared to the results of the previous experiments. The positive result of the experiment can be considered as experimental hypothesis confirmation of the ether existence in nature as material medium. Measuring method. Ether model proposed in the works 4 through 6 was accepted at making the experiment. The following effects should be observed experimentally within the original hypothesis. The anisotropy effect. The velocity of electromagnetic waves propagation depends on radiation direction. That is stipulated by the relative movement of the solar system and ether, the medium, responsible for electromagnetic waves propagation. The height effect. The velocity of wave propagation depends on the height above the Earth's surface. That is stipulated by the Earth's surface interaction with the viscous ether stream material medium responsible for electromagnetic waves propagation. The space effect. The velocity of wave propagation changes its value with a period per one stellar day. That is stipulated by a space galactic origin of the ether drift, the medium responsible for electromagnetic waves propagation. Thus, the solar height, astronomical coordinate of the solar system movement apex, will change its value with the period per one stellar day, as well as any star owing to the Earth's daily rotating. Pardon me. Therefore, the velocity horizontal component of the ether drift, and hence the velocity of electromagnetic wave propagation along the Earth's surface, will change the values with the same period. The hydroaerodynamic effect. The velocity electromagnetic waves propagation depends on movement parameters of viscous gas like ether in directing systems, for example, in tubes, that is, stipulated by solids' interaction with the ether stream, material medium responsible for electromagnetic waves propagation. As it is known, the laws of fluids and gases' motions and their interaction with solids is learnt by hydroaerodynamics. This effect apparently should be called as ether dynamics effect, with reference to ether dynamics. It can be seen that the height effect is referred to the ether dynamic effect class. However, in the work, by virtue of methodical reception distinction used for their discovery, the effects are indicated as separate. My bad. According to investigating purpose, the measuring method should be sensitive to these effects. The following model statements are used at measuring method development 4 through 6. Ether is a material medium responsible for electromagnetic waves propagation. The ether has properties of viscous gas. The metals have major ether dynamic resistance. The imagination of the hydroaerodynamic ether dynamic effect existence is accepted as the initial position. The method of the first order, based on known regularities of viscous gas movement in tubes 27 through 28, has been proposed and realized within the optical electromagnetic waves band in the work for measuring of the ether drift velocity and ether kinematic viscosity. The method essence is in the following. Let's place a tube part in a gas stream in such a way that the direct tube axis will be perpendicular to the stream velocity vector. In this case, both open tube ends in relation to an exterior gas stream are in identical conditions. The gas pressure drop does not occur on the tube part, and the gas inside a tube will be immobile. Then we shall turn a tube in such a way that the velocity vector of a gas stream will be directed along the tube axis. In this case, the gas speedy stream will create a pressure drop on the tube ends under an action of which there is a gas stream in a tube soon. Under which action of stream there's a gas stream in a tube soon. The stabilization time of a gas stream in a tube and this stream velocity are determined by the values of gas kinematic viscosity. The geometrical tube sizes and the velocity of an exterior gas stream, 27 through 28. Let's mark that the development of constant gas stream in a tube lasts a terminating interval of time. The ether is a gas-like material medium responsible for electromagnetic waves propagation according to the accepted hypothesis. It means the electromagnetic wave velocity regarding the It means that the electromagnetic wave velocity regarding the observer is the sum wave velocity vectors relative to the ether and the ether stream velocity with regard to the observer. In this case, if an optical interferometer is created in which a beam drives inside a metallic tube and another outside of a tube in the ether exterior stream, and to turn the interferometer in the ether drift stream, it can be expected that in such interferometer, during a stabilization time of the ether stream in a tube, the band's offset of the interference pattern regarding to the original positions of these bands on the interferometer scale should be observed. Thus, the value of band's offset will be proportional to the ether exterior stream velocity and the stabilization time. The band's return time to the original position will be defined by the ether kinematic viscosity value. Hence, the proposed measuring method enables to meter the ether drift velocity values and the ether kinematic viscosity. The proposed measuring method is a method of the first order, as it is not required to revert a light beam to the initial point, as for example Michelson's interferometer. Let's calculate the interferometer pattern or parameters. For the stream analysis of the gas-like ether, we shall use the mathematical hydrodynamics apparatus, which is advanced in the works 27 through 28 at the problem solving connected with the stream of viscous incompressible fluid. The use of such, let me take a drink of water 1 second.
You're PDF water.
Yeah. Galaev water, geez.
So those 27 and 28, those are the things that I was trying to track down. That's what Eric's already working on. So I'm just gonna leave that alone. I just realized that.
Nice. Awesome. So, the use of such solutions for gas stream analysis is true if the following requirement is performed. 0.5 MA squared is much less than 1, where MA or M times A equals W sub PA, C sub S to the negative 1 is a Mach number. W sub PA is an average gas stream velocity on a tube section. C sub S is the gas sound velocity. At the requirement implementation of equation 2, it is possible to neglect the gas pressure effects and consider the gas stream as the stream of incompressible fluid. On the data of the experimental works 1 through 3 and 7 through 9 and 10, the ether drift velocity W near the Earth's surface does not exceed the value of W being approximately 10 to the 4th power meters per second. In the work of citation 6, the sound velocity in the ether is estimated by the value of C sub S is approximately 10 to the 21st meters per second. That essentially exceeds the light velocity. Even if to consider that C sub S equals C, we shall receive that MA is approximately 3.3 times 10 to the negative 5. Hence, the requirement of equation 2 is performed. The stream of a gas like ether can be considered as a stream of viscous incompressible fluid, and the use of hydrodynamics corresponding mathematical apparatus is true for ether stream analysis. Laminar and turbulent flow streams are distinguished in hydrodynamics. The laminar fluid stream exists if the Reynolds number, Re, drawn up for a stream does not exceed some extreme value, Re, sub E. Citations 27 through 28. Reynolds number being less than Reynolds number sub C. The Reynolds number for a round cylindrical tube is defined by the following expression. Reynolds equals 2A sub P, W sub PA, V to the negative 1. Where A sub P is the interior tube radius, V equals, what is this one again?
Mu and rho, I think.
Mu and rho. Cool. Wait, I don't think that's mu. Oh, well, yeah, you're right. It's mu. Okay. Mu and rho. Cool. So V equals mu rho to the negative 1 is kinematic fluid velocity. Mu is the dynamic viscosity. Rho is the fluid density. Depending on the exterior stream nature and the requirements of the fluid influx into a tube, the values Reynolds sub C are within Reynolds sub C is approximately 2.3 times 10 to the 3rd, iterating to 10 to the 4th. At Reynolds less than 2.3 times 10 to the 3rd, the fluid stream in a tube exists only as laminar and does not depend on an extent of an exterior stream turbulence. The following features are peculiar for a steady laminar fluid stream in a round cylindrical tube. The particle movement pathways are rectilinear. The maximal fluid stream velocity, W sub pmax, takes place along the tube axis and is equal to W sub pmax equals 0.25 delta PA squared sub P times mu to the negative 1 times length sub P to the negative 1, where delta P is the pressure drop on a tube part with the length L sub P. Delta P equals 0.25 That is not lambda, right? That is the, what's that one called again?
Gamma.
Gamma gamma sub PL sub PA sub P to the negative 1 PW squared sub PA. Gamma P is the coefficient of a round tube resistance, which is equal gamma P equals 64 Reynolds to the negative 1 at a laminar regime of fluid stream. The maximal stream vector velocity W sub PMAX is twice more than mean fluid velocity. W sub PMAX equals 2 times W sub PA. And here's the diagram showing the gas that they're sending over the metallic chamber that they then rotated. The stream velocity distribution on a tube section is called as Poiseuille's parabola and looks like this guy here. W sub P times R equals W sub PMAX 1 minus R squared A sub P to the negative 2, where R is the coordinate along the tube radius. The laminar stream transferring into a turbulent one takes place not fluently but by jumps. At transferring through the extreme value of a Reynolds number, the tube resistance coefficient increases by jump and then slowly reduces. The following features are peculiar for a steady stream of viscous liquid in a round cylindrical tube of turbulent stream. The pathways of particle movement have scattered nature. The resistance coefficient of a round tube is equal to delta, right? No. Gamma, thank you. Is equal gamma P equals 0.3164 Reynolds to the negative 0.25. The velocity distribution on a tube section is almost uniform with their sharp reduction up to 0 point in a thin layer near the wall. The maximal velocity increase above the mean order value is about 10 to 20%. That's in citations 27 through 28. W sub PMAX is approximately 1.1 iterating to 1.2 WPA. It will be shown below that in the experiment requirements, as a rule, Reynolds is more than Reynolds sub C. Therefore, in the work, we shall be restricted by the estimations performed for the ether turbulent stream. Get a little highlight on that because that's a pretty important note. Let's consider the method operating principle. In the figure 1, the part of a cylindrical round metallic tube with the length L sub P, which is the ether stream, ether drift, is shown. The ether stream is shown in the figure as slanting thin lines with arrows that indicate the direction of its movement. The tube longitudinal axis is located horizontally, and along with the ether drift velocity vector is in a vertical plane, which represents the figure plane. The two balls have major ether dynamic resistance, and the ether stream acting on the tube's surface side area, the ether inside a tube, does not move. The ether velocity stream stipulated by the horizontal velocity component of the ether drift W sub H creates the ether stream in a tube, which goes with the mean velocity W sub PA. Let me get another little highlight. It can be spoken that the metallic tube is the routing system for the ether stream. Let me get another highlight. Let's go ahead and do that one in this one. Let's turn a tube in a horizontal plane in such a way that its longitudinal axis, actually, let's change this real quick, that its longitudinal axis will take up a position perpendicular to the plane of the figure 1, or that is similar perpendicular to the velocity vector of the ether drift. Pardon me. In this position, both opened ends of a tube will be in identical conditions regarding the ether stream. The pressure differential, delta P, does not occur, and according to equation 5, the ether stream velocity in a tube is equal to a 0 point. At the moment t sub 0, we shall turn a tube into the initial position. The horizontal component of the ether drift velocity W sub h will create a pressure drop, delta P, on the tube ends, under operation of which the ether stream will be developed in a tube. In the work of citation 28, the problem about setting into motion a viscous incompressible fluid being in a round cylindrical tube operating of the suddenly appended constant pressure drop delta P is solved. Let's reduce the formula of the velocity distribution of fluid stream in a tube. 28 is what again?
Those guys that did the what was it called? The hydroaerodynamic stuff. Like, so they mapped out like how fluids move in relation to different materials.
Interesting. Okay, cool. Thank you. You know what? I'm not going to read this whole equation.
Oh, dude, come on. Really?
Let's just zoom right in on it for the stream.
Yeah.
Take your screenshots. Send Galaev your emails. So there it is, where T is the time. Oh boy, what is this one?
It looks like a V with a line through it, dude. So you call it whatever you want, bro. I'm not going to judge you.
Toby sub K is the equation of roots. J sub 0 times Toby K equals 0. J sub 0, J sub 1 are Bezel's functions of the 0 and first orders. The first two summons in square brackets express steady at T iterating up to, or T to infinity, laminar stream of fluid, and correspond the mentioned above Poetzel's parabola from equation 8. So, at a turbulent fluid stream, according to equation 9, the velocity distribution on a tube section is almost uniform. We shall consider that the fluid stream velocity is equal to W sub PA on the whole tube section. The value of gamma, right? Gamma P?
Yeah.
Yeah, gamma P. Thank you. Gamma P of the round tube at a turbulent fluid stream should be used at the value calculation W sub PA, except the thin near wall layer. In this case, the expression of equation 10 at R equals 0 will be like.
What will it be like, Toby?
W sub P times T is approximately W sub PA. Is that an integral, right?
No, that's just a bracket, and then
just a cool bracket.
Yeah, just a different bracket. But yeah, so that'll be represented by equation 11 there. You don't have to do it,
bro. It's got Toby in it, so I was kind of excited.
Yeah.
I'm gonna judge you, man. I'm gonna judge you.
The expression 11 describes the process of a fluid stream defining in a round tube. It follows from 11 that as T goes up to infinity, the value is WP T to WPA. Both parts of the expression of 11 should be divided into the value of constant fluid stream velocity in a round tube, WPA. In this case, the time variation of fluid stream dimensionless velocity, W sub P times T divided by W sub PA, will be like that is shown in figure 2. In the figure, the values of dimensionless velocity, W sub P, T divided by P, W sub PA, are given on an ordinate axis. The values of time are given on the abscissa axis, as is shown above. The requirement of equation 2 is performed, and the ether stream can be described by the laws of thick liquid motions. Then we shall speak about the ether stream further instead of fluid. In the figure 2, we'll allocate the... Here's old figure 2. This is them trending towards 1 here.
Yeah, so as it's trending towards 1, when it hits the 0.95, he's good to go to just assume it's at that threshold where it, approaches 1 at the optimal conditions or whatever. So like 0.95 is as good as 1 for the scale that he came up with.
So yeah, just to go back to read that last. In the figure 2, we'll allocate the interval of time t sub 1 iterating to t sub d, during which the ether stream velocity in a tube changes from 0 up to 0.95 w sub pa. We shall call the ether stream regime on this time interval as the dynamic one. We shall call the ether stream regime at t is greater than t sub d as the steady stream regime. Let's skip a light beam along the tube axis. It can be written down that the phase of a light wave on a cut with the length L sub p will vary on value j, which is equal. I need to memorize these. This is getting kind of ridiculous. But what the heck is this one?
I think that's rho, isn't it? So rho equals 2 pi the integral of L sub p v to the -1. Oh no, I'm sorry, that's not an integral. That's F is the electromagnetic wave frequency. Sorry, it looked like a little integral thing.
Yeah. Where F is the electromagnetic wave frequency, V is the light velocity in a tube. According to the original hypothesis, the ether is a medium responsible for electromagnetic waves propagation. This implies that if in a tube with the length L sub p there is the ether stream, the velocity of which changes in time. So the phase of a light wave measured on a tube output should change in time according to variation in time of the ether stream velocity W sub p times t. Then the expression 12 will be like rho maybe times whatever this, we'll say rho. Rho times t equals 2 pi f times L sub p c plus or minus W sub p times t to the -1, where c is the light velocity in a fixed ether in vacuum. In expression 13, the sign plus is used when the direction of the light propagation coincides with the ether stream direction in a tube, and the sign net minus is used when these directions are opposite. In the work, the optical interferometer is applied for measuring value of rho times t. Radodatvensky's interferometer schema is taken in citation 29 as the basis, which is supplemented in such a way that the light beam drove along the empty metallic tube axis in one of the shoulders. Which is supplemented in such a way that the light beam drove along the empty metallic tube axis in one of his shoulders. Okay.
So he's got like a. Do you know the configuration? I think it shows it. If you want to scroll down real quick, it'll show it. You can see what he's talking about. It should have the diagram.
I think it's above.
Oh yeah, right there.
Yeah.
Sorry, go down one. Yep, my bad. Right there.
Oh,
There it is.
Yeah, so one of the arms is exposed to the free ether wind, and the other one is that tube that they have.
Yeah. Her one's in the chamber and
Yeah.
getting the one experimental apparatus, and then
Is the T intended to be time and the pi intended to be the rotation, so that when they rotate it through as they're rotating the whole board, that's how they're scanning the interferometry. Isn't that how that's supposed to be achieved? Like
Yeah.
the whole board
Mhm.
is
Yes,
rotated,
you're
right?
Yep.
Absolutely. Yeah. And so what he was saying too, like at the beginning, they take their baseline where it's not where it's not going with where it's perpendicular to the ether wind, and then they align it with the ether wind, and they take that difference there and the fringes to get the velocity of the ether wind, and then further, they break down like well, that tube is like really what there is the deciding factor, right? The difference produced by being in alignment with that tube is where they're
Yeah.
getting.
That's
It's
yep.
it's
Yep,
pretty
that's
awesome, isn't it? It's a great experiment. Like
yeah.
this dude's well thought it out.
Yeah, this is great detail. I mean, I've researched this experiment, but this gives you a lot more detail. That's definitely.
Cool. Actually, that's confusing. People are gonna think that's a vector. Huh. Okay.
Yeah, what you guys are doing is awesome. Just letting you know. I mean,
Thanks,
and
man.
there's a
We
lot
appreciate it.
to this stuff.
Ye-
A lot of
It's
math.
it's one of the most fascinating aspects of like actual science that I've found. I mean, the fact that you could split a light beam, recombine it, and get a proportional velocity relationship
Yeah.
it just blows my mind.
Yeah, it's
Yeah,
pretty insane.
it's pretty crazy.
So where were we?
Let's see. Go down a little bit. We were right there by your boy Razan Doskoskaskov.
Okay, cool.
Yeah.
Let me. Sorry. Okay. All good. My bad. Okay. 1, illuminator. 2, a metallic tube part. 2, a metallic tube part. 3, eye fragment with a scale. P sub 1, P sub 2, flat, parallel, semi-transparent laminas. M sub 1, M sub 2, mirrors are shown on the schema. The beam course is shown with the thick lines and arrows. The light beam in a tube pass along the axis and is indicated with a broken line in the figure. The tube length is L sub P, approximately equal to P sub 1, M sub 1. The clusters P sub 1, M sub 1, and P sub 2, M sub 2 are mounted by two parallelly. M sub 1, M sub 2 are mounted opposite each other on a small angle. The angles I sub 1, I sub 2 are the angles between normals to the mirror planes, M sub 1, M sub 2, and the beams dropping on them. The intervals are P sub 1, M sub 1 equals M sub 2, P sub 2 equals L sub 1, M sub 1, P sub 1 equals P1, M2 is approximately LP. In a classical sense, if the ether drift influence isn't considered, the Rozhedetvenski's interferometer operating is reduced to the following. The light beam with the wavelength lambda is divided P sub 1 into two beams, after the reflection from M1 and M2 and passing P2 are parallel with a phase difference from citation 29. What is this one again? This is delta. Delta equals 4 pi L1 lambda to the negative 1 to the times cosine to cosine I to the sub 1 minus cosine I sub 2. The angles I sub 1, I sub 2 are established at the interferometer adjustment so that the interference pattern should be observed. The adjustment clusters are not shown on the schema symbolically. In a tuned interferometer, the value is delta equals constant. In the right part of the figure 3, the family of arrows means the stream direction of the ether drift velocity or the ether drift horizontal component velocity. This stream velocity is equal to W sub h. if to arrange the interferometer clusters on a horizontal rotated background, such instrument can be turned in the ether stream. The rotation axis is perpendicular to the figure planes and is indicated as A sub I. In the interferometer figure 3, the band position of an interferometer or of an interference pattern regarding the I fragment of scale 3 is defined by the phase difference of the light beams, which are distributed on the paths P1M2, P2, and P1M1, P2. In the figure 3 of figure 3 ether stream is directed towards the light propagation direction along the beams P1, M2, M1, P2. In this case, according to equation 13, we shall write down expression for the phase difference delta rho times T between the beams P1, M2, P2 and P1, M1, P2. 1 plus 1 equals 2. Where delta is constant, the value of, so this obviously I just kind of didn't
Didn't feel like doing that one. You don't want to hit up delta rho T equals 2 pi over the frequency
Who's
is
making you
the
guys do this? What happened? I'm confused. It's kind of fucking miserable. Like, what are you doing?
Yo,
What's up,
did you
bro?
know about ether? Did you know about ether viscosity, my man?
I did. Bennett pointed out all the ways they've measured the various properties of the ether that others say they don't exist, but they have all have values. So
Check this one out. So they've got this interferometer. Here it is. Here's the detector. So here's the light emitter. It gets split. Here's the detector where it gets recombined and hits the detector here. And they've got this metallic chamber that around one of the paths, and then the other path doesn't have it. And then they blow a gas past it. And then they've got this other diagram here showing this is the metallic chamber, right? And so this is the light wave going through the metallic chamber. And they're actually able to detect how much of that translation of motion of that laminar flow from the gas actually gets through that metallic chamber. Like to see how viscous it really is. Like, is that translation actually detected through metal?
Well, there's a viscous fluid inside the chamber, though, right?
Yeah, it's not a vacuum tube. I don't.
it's measuring the viscosity of the ridiculous
They
ether around it.
they have like the equation accounts for both. Like they're using
a gas in
laminar
there. Yeah.
specifically using like the laminar flow functions, like not like they're able to determine when it's laminar and when it's turbulent by rotating the whole apparatus and kind of determining that I mean that's essentially what which equation is doing. What these equations are doing, I believe.
Yeah.
But yeah, so they're able to detect that translation and determine essentially how useful or useless the dielectric insulators or metals are for affecting your interferometer reading. So cool. I think we're only an hour and 10 minutes. I guess we're making pretty good time. Where are we?
Let's see.
I need to take like a 2-minute break.
Yeah.
I'm gonna go walk the dog and then try and get into whatever you guys are doing.
All right, cool. Try and get into
what
respect.
a cool dog whined patiently for an hour and 20 minutes. It's
Nice.
like, I'll take you out. Now I'm like, wait, but okay, no, I'll really take you out. I'm sorry.
Yeah,
we're
Delta.
right
Yeah, we're right around there. Actually, that's where I
Yeah.
was. So Delta P or Delta Rho. So where Delta is a
Delta Rho. That's where we left off. You're right.
Yeah. Let's see. Where delta is a constant and the value of which is defined by the expression in equation 14. Let us simplify the expression in equation 15. For the purposes, we shall introduce the identification. Oh yeah, we're down here, aren't we?
No. You're good. You're
Oh,
good.
okay.
My bad. I
You're
I
straight.
just
Oh, come on,
accidentally
cat.
clicked on it.
Get off my desk. Hold on, 1 second. Got a cat attack.
Yeah, no problem. I'm gonna be a minute, but go ahead and keep
Yeah.
reading when you're ready.
Yep, you're good. For this purpose, we shall introduce the identifications accepted earlier, allowing that the beam phase difference m sub p times m sub 2 and m sub 1 and m sub 2. I'm sorry, yeah, m sub. Man, said that backwards. Difference in m sub 2 times m sub p and m. Fuck, man, getting it. M sub 2, p sub 2, and p1 and p sub 1 does not depend on the interferometer orientation regarding the ether stream direction and is equal to a 0 point. The expression for the value delta rho t will be like equation 16, where we have all of that. And see, the first member of the expression 16 of equation 16 describes the beam phase variation of P1 and M2 depending on the ether stream velocity in the tube W sub PT. The second member of the beam phase variation M sub 1 and P sub 2 depend on the ether exterior stream velocity W sub H. Let's reduce the expression in square brackets to the communal denominator and allowing that C squared is much less than, let's see, W sub H WP T minus C WPT minus CW sub H. Yeah, all the, so the, what is this? The reduce the expression brackets of the following. So, what's he doing? The difference in the orientation of, oh, you can't scroll up. What's happening to the light beam? Yeah, okay, there we go. Can you scroll up to the diagram real quick? Okay, so what I think they're describing there is basically the phase difference when they're reorientating it, right?
Not sure. Can we go back?
Yeah. So wait, hold on. So M1 and M2. So yeah, it's like the cross diff. Okay, it's the cross difference in when he changes the orientation, because like it'll be, this one will be going with it and I'm sorry, it'll be going with or against the stream when they change orientation, but it, like, this one's exposed and then that one's not exposed. So it's like the cross difference between them when he changes orientation too. You know what I'm saying?
Yeah, makes sense.
Okay. All right, scroll down, please. I don't know how to read all that mathematically, but that's what he's doing. That's what I just read. All right. So it follows from the expression 17 that the difference in the phase delta rho t between the beams and is proportional to the difference of the ether stream velocity in the tube, and that's the velocity in the tube. That's the variable for that. In the ether exterior stream W sub H, let us consider the interferometer operating in its steady regime at t trending to infinity, according to the expression 11 in Figure 2. WPT and sub t going to infinity, and the velocity of that going to equals the velocity of that going to WPA. It will be suspected that owing to the small value of the ether dynamic velocity, celestial bodies move in the ether, and the ether stream velocities in the tube regarding to the small length will not differ essentially from the ether exterior stream velocity, and it is possible to write down that WPT t going to infinity equals WPA is approximately equal to the ether wind velocity. The correctness of this supposition in the work is determined experimentally and shown below. In this case, the expression 17 is the fraction numerator in square brackets is equal to the 0 point, and this will be expressed by 2 pi delta rho t sub t going to infinity is approximately equal to delta. Hence, in the steady regime of the interferometer operating with the metallic tubes does not differ from the Rosendinsky Rosendinsky's interferometer operating. In both interferometers, the band position of the interference pattern will be defined by the original phase difference, delta. The interferometer with a metallic tube in a steady operating regime is not sensitive to the ether drift velocity and cannot detect the availability or the absence of the ether drift. Let us consider a dynamic operating regime of the interferometer. Let us unroll the interferometer, see figure 3, in the horizontal plane at 180 degrees. As the direction of the light propagation has varied in relation to the ether drift stream to the opposite one, in expression 17 would be like this, whatever. Yeah, it would be like equation 19. Cool. All right. And then according to the expression 11, the figure 2, the inequality of ether wind stream inside the tube will be greater than the velocity outside the tube.
Sure. Yeah. Wait. You want me to look?
Yeah, I guess. It takes place at the time interval t. Then what was that going to, or what is the 3 dots? What did you say that was?
Iterating to, I
Oh yeah.
believe.
Oh, iterating too. Yeah. Now that's what it is. WH is the ether wind velocity outside of the tube. So,
Perfect.
hence, in the dynamic regime of the interferometer with the metallic tube is sensitive to the velocity differential of the ether exterior to the streams WH, and the ether stream inside the tube is WPET. We shall discover the band's offset value of the interferometer pattern regarding their position in the interferometer steady work regime as follows. Let us take the differential in the expression of equation 18 and 19 and divide both portions found in the expressions into 2 pi, and we shall receive equation number 20. The expression left-handed part of equation 20 is equal to the required interference pattern offset, which is expressed by the number of electromagnetic wave periods. Sorry. This reference to the visually observed interference pattern in equation 20 describes the value variation time of the visible band offset of this pattern regarding their original position, dt. The visible band of the interference pattern can be the offset measurement unit, taking into consideration. Yeah, definitely. Can you make that? Yeah, like a red or like a yeah. Thank you. Taking into consideration that this ether stream. Let's see what this. Yeah, make it ether colored. I like it.
Yeah, ether colored.
Is that what you were thinking? Taking into consideration that the ether stream in a tube can have a different direction opposite to the selected on the figure 3. Generally, it is. Generally it is not to receive dt. So equation 21. In this expression, the 21 is the plus sign when used with the light propagation when the direction coincides with the direction. Let's see. Oops, within the direction of the interferometer dynamic regime in the tube in the minus sign when it's in the opposite direction. So when it's perpendicular and going with the, or in alignment with the wind. So according to the expression 11 in figure 2, the instant that t sub 0 equals 0, the ether stream velocity in the tube is equal to 0 as well. Then in equation 21, we shall receive that at the instance t0, the offsets in the interference pattern accepts the maximum value equal to equation 22. And in the steady regime, when the ether velocity is at the tube is equal to the speed inside the tube where t is going to infinity is equal to the speed outside of the tube. The bands offset regarding their original position is equal to 0. The dependence of dt, so the what is that? That was the fringe amount displacement, right? Or no? No, never mind. Can be obtained. No, it is. Can be obtained with the dependence
I think you're right.
of the speed, the ether speed inside the tube versus the WPA. I forget what the WPA was, but which is shown in Figure 2.
We need to go.
What's that?
It's a big part of the whole thing here.
Yeah. WPA.
That's the
Okay, wait. During which the ether stream velocity in the tube changes from 0. Oh, that's when it hits its that threshold.
yes.
Okay, so that's when
Let me
that's
double check that. I think you're right. Constant fluid stream velocity in around 2 WPA. So it's based on the same thing. Yeah, that makes sense.
Okay.
So it's based on once they hit that. That's how they're calculating it, is by using this, what you were saying right here. And what they're calculating is the constant fluid stream velocity in the round tube.
constant fluid stream velocity in tube. Okay. And then WPT was
I believe.
Let's see, ether speed in the tube. Let me just write these down real quick, and then yeah, then we're good.
Okay. Yeah, the fluid stream velocity is equal to WPA. Okay.
So it's just basically how to start counting, like the threshold for when the effects reaches its like maximum.
Is this where we were?
Yeah,
Is it?
yeah, I think.
Okay.
Yeah. Okay, so let's see. Equation 24, the interferometer and the necessary proposed measuring method relations or realization. Let's see. The data of the interferometer tube sizes are not necessary for the purpose measuring method realization, and the expression for the tube interior radius calculation, A sub p, can be obtained as follows. Let us divide the parts of the expression 11 on WPA, which is the constant of the speed, ether speed inside of the tube when it reaches that 95 thing, 0.95 threshold, and allowing that at the moment of time t sub d in Figure 2, the ratio of all of that will be equal to the ether constant.
Yes, that's when they're hitting that
When they
that
hit that
critical point.
when they hit that, then we shall write that down as equation number 25, where all of this and the summation of all of that will be equal to that that 0.95 threshold. All right.
Oops.
You're good.
I'm just gonna drop that in chat. It's just a fun one for someone to do in their spare time. If anyone wants to knock that equation out real quick.
Anyone wants to tap that out? Nice.
If to be confined, or do you want me to take over?
Yeah, you're good.
If to be confined by the estimation accuracy, no worse than 7%, so the series and expression number 20 or expression number 25 can be exchanged by its first member. Let's substitute in the equation 25 the numerical values Toby sub k and j sub 1 times Toby sub k. For the information we shall give these values, Toby. All right, that's gonna be distracting if I keep using my own name.
Yeah.
For like listeners. Let's do something else. the heck is that thing? Um, Oh,
Yeah.
there's the good chart. This is the good one. I drop this in the chat.
Nice.
But I do not see that one in here.
Yeah, I don't even see that one in here either. So let's just
Call it Trident sub 1.
yep. Trident sub 1.
Trident. I like it. I like it. Okay. So where were we? Here we go. Trident sub K and J. So I'm gonna go back to before I started using my own name. Let's substitute in equation 25 the numerical values Trident sub K and J sub 1, Trident K. For the information we shall give these values, Trident sub 1 equals 2.4048. J sub 1 times Trident sub 1 equals 0.5191. We shall receive A sub P is approximate to 1.37 times T sub D V to the half power. That's equation 26. And that allows us to calculate such the interferometer design parameter as the tube radius AP. At calculation, the value TD is selected coming from the time which is required for the implementation of visual or tool readout of bands offset value D. The data of ether kinematic viscosity value V will be reviewed below. The tube length LP can be found with the expression 24, which we shall receive this guy, expression 27, where V D min times T or D min T0 is band's offset minimum value of an interference pattern, which can be digitized with the selected I fragment and scale. WH min is the minimum value of the ether drift horizontal component velocity, which should be measured by the interferometer, the interferometer sensitiveness. The ether kinematic viscosity. The data of the ether kinematic viscosity value V are necessary for the measuring method realization. Let's estimate the value V relying on the following. In the work of citation 5, the photon formation mechanism is represented as the oscillating result of excited atom electronic shell in the ether and the Kármán's vortex track as hydromechanical photon model is proposed. One more time.
Never heard of it, but we're definitely gonna have to check out. Check
Yeah, there's a reason it's highlighted. I remember being like, "What?"
in the work of 5. I think 5 was referring to Miller.
It's a pretty decent, it's my favorite photon explanation, favorite invocation of photon I've ever heard.
The photon formation mechanism is represented as as the oscillating result of an excited atom electronic shell in the ether, and the Kármán vortex track is a hydromechanical photon model is proposed. Yeah, I mean, I'll listen to that.
Vortex track, that's crazy.
You guys weren't in the club, so you don't know the terminology. I wasn't there either, so I have no clue.
Dude,
Trident's good. I like that. That worked well. All right, so in other words, the photon formation is stipulated by the ether stream turbulent regime of the excited atom streamlining by the ether, oscillating in the ether. The turbulent pulsation propagation in the ether is perceived by the observer as the light emission. In the work of citation 28, it is shown that the existence of pulsation movement is possible in fluid volume if the Reynolds number is not lower than some extreme value equal to Reynolds ER equals WV to the -1, equation 28, where W is fluid movement velocity, D is the characteristic of a streamlined body. In the work of equation 28, it is obtained that Reynolds ER is approximately 425. With reference to our problem, the values W, D, V are accordingly the ether movement velocity, atom diameter, the ether kinematic viscosity. From the expression 28, we shall find V is approximately equal to WD Reynolds sub CR to the negative 1. We shall call the obtained ether kinematic viscosity value as the calculated ether kinematic viscosity value V sub C. Let's calculate the value V sub C. As the ether stream velocity W, we shall accept the offset velocity of the electronic atom shells in the immobile ether at a photon emission. Yeah, okay. Let's consider that this velocity does not exceed the light velocity. W is greater than or equal to C. The diameter of atoms, as it is known, has the value order D is approximately equal to 10 to the negative 10 meters. In this case, with the equation 29, we shall receive VC is greater than or equal to 7.06 times 10 to the negative 5 meters per second meters squared per second to the negative 1. And that is equation 30. The performed estimation has shown that the ether kinematic viscosity calculated value corresponds to the work imaginations about the ether as gas-like medium with real gas properties. So, the kinematic viscosity values of 12 gases spread in nature are within 7 times 10 to the negative 6 meters squared per second to the negative 1. Carbon dioxide up to 1.06 times 10 to the negative 4 meters squared per second to the negative 1 helium. And now let's take a little peeky boo at figure 5, the interferometer structure. Is this the metallic chamber here?
Yes. Yeah.
Okay. Optical interferometer. The calculated ether kinematic viscosity value allows to calculate the interferometer parameters. With the expression 26, we shall determine the tube radius. If the value TD is supposed to be equal 1 second, we shall receive that at the interferometer creation it is necessary to apply the tube with the interior radius AP is approximately equal to 0.05 meters. We shall determine the tube length LP with expression 27. If to suppose the values D min is equal to 0.05, WH min is equal to 20 meters per second, and apply the light source with the wavelength of lambda equals 6.5 times 10 to the negative 7 meters, so the required tube length is equal to LP, approximately equal to 0.49 meters, excuse me. The optical interferometer was manufactured for conducting measurements. Schematic figure of the device, or top view, is shown in figure 5. Aha. That's top. I'm like squinting my eyes. I'm like, what are you talking about?
Dude, it looks like a side view. It looks like a...
I know. Look. See, honestly, this is the first time I've even tried to make sense of this diagram. Every other time I looked at it, it just looked like it looks like the head of a razor.
Yeah, every other time I look at it, I immediately tune it out, block it out, and defer to the first picture.
Yeah, every other picture in here. This one.
Then the top-down one, right?
Yeah, I don't know, man. Okay. So there's the tube, I guess.
Mm-hmm.
Take a drink of water 1 second. All right. In figure 5, The identification. Let's get a little screenshot of figure 5 here.
Yeah, good call.
So I'm gonna copy it, and then I'm gonna drop it in the chat. And then go back to where we were. Hold on. All right, let me change my game plan here. This will work. Okay. In figure 5, the identifications of the basic clusters are kept, which were introduced at viewing the interferometer schema, figure 3. 4 and 5, the interferometer adjustments clusters, 6 and 7. Okay, wait, hold on. Figure 3. 4 and 5, the interferometer adjustment clusters, 4 and 5. 6 and 7, racks for fixing flat parallel semi-transmitting laminas and mirrors. Aha. Okay. So that was 6 and 7. 6. Okay, yeah. 7. Okay. So that's what it is. Okay, so these are the flat parallel semi-transmitting laminas and mirrors. So that's what these things are. And so then now you can kind of tell this is the emitter, splits it, boom, 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 detector. Still kind of a weird diagram. 9 power supply accumulators of the illuminator. Or wait, I think maybe I have it backwards.
Toby, I'm
One.
not really seeing what the other image. I'm not sure if it's just me,
Oh,
but
it's the one I posted in chat.
oh, okay.
Sorry, I'm like mousing over it for my recording and the stream that I'm doing, but I guess I didn't really think about how you guys can't see what's going on. Actually, let me double check that my stream is still up. Yeah, okay, that's cool. So which is great. Thank goodness my internet is working finally for a period of time. In figure 5, the identifications. So yeah, where was 1? I wanted to see, or he hasn't described 1 yet, has he? No. Okay. So 10, the illuminator switch. 11, the eye fragment fixing cluster. 12, the heat insulating housing. Well, okay, so the outer frame are shown additionally. The frame 8 is manufactured of steel profile with 11 like section. The wall thickness is 0.007 meters. The profile height is 0.02 meters. The frame length is 0.7 meters. The width is 0.1 meter. The interferometer clusters are fixed on a flat frame surface. The racks, 6, 7, are manufactured of rectangular copper tubes with interior section 0.01 meters times 0.023 meters. The light beams pass inside these tubes. The interval between beams is P1, M2, and M1, P2 is equal 0.12 meters. On racks in the points P1, P2, the flat parallel semi-transmitting laminas. In the points M1, M2, mirrors are installed. In the manufactured interferometer, the flat parallel glasses with the thickness 0.007 meters were used as semi-transparent laminas. The laminas, mirrors, and clusters of their fixing in Figure 5 are not shown symbolically. Each of the clusters 4 and 5 allows to change the rack's position in the 2 orthogonal related planes. The tube 2 is steel with the interior radius AP equal to 0.01 meters. The me zoom in. The tube length is LP, equal to 0.48 meters. The clusters of the tube fixing on 5 are not shown symbolically. The semiconductor laser with a wavelength of lambda approximately equal to 6.5 times 10 to the negative 7 meters was applied as the illuminator. The optical paths in the interferometer are located in a horizontal plane. The interferometer was located on a rotated material table, which was manufactured of an organic glass with a thickness of 0.2 meters. The heat insulating gasket was put between the frame and the material table. I'm going to go ahead and highlight some of this. I don't know why I didn't think it was important last time. The interferometer was closed by a common housing of 6 layers of a soft heat insulating material. The thickness of such coating was about 0.025 meters. In the figure 5, the housing perimeter is shown. The housing background was the box rectangular section of the interior sizes. 0.22 meters. That was the width. The height was 0.11 meters. The length was 0.8 meters. The box was manufactured of a cardboard with a thickness of 0.007 meters. Show me a cereal box. In
So
the
did
box.
he come crash your party too? Everything went well down here then? With the muck on the loose. Yeah. Like, dude, he came in. He was the first person to speak to Lindsay. I didn't even know he came in. I was looking the other way. Then I heard him ask a question. I was like, oh, fuck. Wait. And then it was like respectful and it wasn't bad. And I was like, oh, thank God. But I can't risk that again. Sorry to muck you. Yeah. Like,
He hung around still.
yeah, no, he's a trooper, dude. Like, and at the end, someone was like, "Why'd you mute him?" I'm like, honestly, I didn't want him speaking to Lindsay, and he was like, "Okay." Hey, about the cereal box that he was talking to, with like right into his next thing, I was like, "Okay, that's
Yeah.
cool, that's cool."
So yeah, back to the cereal box. In the box, we face wall on the eye fragment path. In the box, the face wall on the eye fragment part was absent. This opening was closed with a common soft housing. The interferometer rotating was ensured with the end thrust bearing of the diameter of 0.075 meters. The bearing box is located between the material table and support. Or is a bearing box? Okay. Let's go ahead and... Support is provided with the units for the interferometer installation in horizontal position. I'll mark that as actually green because I kind of want to look into that more. The interferometer test. In the manufactured interferometer, the minimum bands offset of an interferometer or of an interference pattern, which could be visually digitized, meant D min equals 0.05. The device stiffness was tested by 2 methods. According to the first method, the instrument frame was mounted on a horizontal surface. The interferometer for one edge of a frame was hoisted in such a way that the frame lean angles to the surface plane reach around 20 degrees. In this position, the interference patterns offset frame, stipulated by elastic deformations of the instrument, did not exceed 0.3 bands, D equals 0.3. According to the second method, the instrument stiffness was tested in a working position. The frame lean angles up to 10 degrees were created by the material table tilt. In this case, the band's noticeable drift was not observed. The stability of an interference pattern to impulsive loads was... Wait, the frame lean angles were up to 10 degrees were created by the material table tilt. In this case, the band's noticeable drift was not observed. That's interesting. The shock The stability of an interference pattern to impulsive loads was tested. The light shocks on the interferometer frame, material table, and support cause short-lived interference pattern wince at the moments of such strikes. Thus, the interference pattern was not destroyed. The band saved in original position after termination of impulsive loads. So just like, hey, we can tell you're jumping up and down.
Yeah, the the calibration of this is really interesting because of how sensitive these things are. So it's nice to have to go through this and like understand what he did to counteract all that stuff too, right? Because a big part of the introduction to this paper and going over the history of Michelson and Miller was the like the sensitivity and the issues that they had, of their time.
The second stage of tests was performed on the terrain selected for experimental investigations. In windy weather, the interference pattern was stable. The observer moving in an intermediate proxy from the interference. Pardon me. The observer moving in an intermediate proximity from the interferometer installation site. The movement of the pedestrians and cars in 20 meters from the instrument installation site did not cause a noticeable offset or band shivering. The short-lived band shivering at cars movement was marked on one of two selected points, which was in 7 meters from the ground road. Thus, the interference pattern was observed and the bands did not change the position. The transport movement in this terrain is insignificant. On the average, 3 to 4 automobiles per day. The interferometer heat tests were held in summer. The device was mounted on an open site. The various device orientation on the azimuth was set in cloudless weather conditions. In a fixed position, the instrument was heated by solar radiation. In these conditions, within 30 minutes, the band's offset did not exceed the value D equals to 0.35, approximately 1/100th band per minute. In cloudy weather and at night, the interference pattern saved an invariable position within 2 to 3 hours. The measuring method sensitiveness to the ether drift required effects was tested at the final stage. You want to take over for a second, Alan?
Yep. Let's see, where were we at here?
Right here.
Yep, gotcha. The measuring second. The measuring method sensitiveness to the ether drift required effects was tested at the final stage. The method of the interferometer application was the following. The instrument was mounted in a horizontal position in such a way that its direct axis coincided with the meridian line, and the illuminator was turned to the north. In such a position, the interferometer's steady work, the observer registered the band's original position of the of the interference pattern regarding the I fragment scale. The value D equals 0 was given to the band's original position. Then the observer changed the position, took a seat at the illuminator, and the interferometer was turned 180 degrees. The rotational displacement was performed within 3 seconds. The rotational displacement was viewed above in the ether, the ether stream in the tube was interrupted. The interferometer transferred into a dynamic operating regime, which is described by the expressions of equation 11. In this interference position, the maximal value of the band offsets and the band release times to their original positions was registered. The interferometer transferred to a steady regime and turned into the initial position. At this stage of test, it was established that after the dynamic regime termination, the band's noticeable offset of the interference pattern regarding their original position. At this stage of the test, it was established that after the dynamic regime,
No, you're good.
the zooming out fucked me up. It was the dynamic regime right there. There were dynamic regime termination. The band's noticeable offset of the interference pattern regarding to their original position was not observed, i.e., the band offset value D T sub T trending to infinity equals 0. According to the ether exterior stream velocity, the value d was behind the interferometer threshold. It can be explained by a small resistance of the interferometer tube to the ether stream movement inside of the tube. Let us consider the case of the ether velocity speed. What was that? Outside of the tube or inside? 1 second. I'm sorry. Yeah, the ether speed inside of the tube approaching a time of infinity equals the speed of the constant fluid that they're trying to reach, which is approximately equal to the ether wind velocity outside of the tube. Whew. Okay, so that's equation 31. This experimental result was used above at the proportional deduction equation 18. At procedure implementation described above, it was marked that the whole time of course of the value d variations corresponded to variations which are shown in figure 4, which did not contradict the original imaginations about the interferometer work. Was figure 4 the can you go up to figure 4 real quick?
Yeah, so hold on real quick. We're on page 10, and we're
Yeah.
at the bottom of the left column.
Yeah.
Figure 4 is... There's 3.
Should be to the left. There we go. Was that it? Yeah,
Variation,
variation
time of interference pattern bands offset in a dynamic interference operating regime.
Okay. So 0.05 seconds. 1 second. Screenshot. Okay, go back to page 10.
Zoom in real quick. There we go.
Yeah. Okay. So let's see here. So they were doing in this case. Let's see the speed outside. Sorry, the speed inside the tube with a t time approaching infinity is equal to the constant speed, which is approximately equal to the speed outside. This experiment results above can be used for the proportion deduction in 18. This procedure implementation described above, it marked that the whole time of the course of value d variations corresponds to variations which are shown in figure 4 that did not contradict the original imaginations of the interferometry work that measured the duration of the dynamic regime meant to be t sub d of approximately 10 what was that word again?
Iterating up to
13 seconds. Is that just a trend? Is that just approaching 18 or just approaching whatever?
This means that you would like build an array out or like it loop through. I mean, I'm just going off of like computer programming, computer equations.
Yeah, no, it makes
like
sense.
Computer logic.
Yeah.
You do like 10, 11, 12, 13. You would
like a series?
iterate through each one of them as like a series. Exactly.
Okay, gotcha. Okay, the value's ambiguity, TD, is stipulated, first of all, by the... Let's see.
That's it, yeah.
Let's see. Yeah, okay, let me get that. Let me just get a screenshot of figure 6 real quick before we send off.
Not a bad idea.
Before we reference it 5 pages later.
Yeah,
Have to come
yeah,
back.
yeah.
All right. Okay.
Oh wait, I need to get the description with it. There we go. Boom. I'll drop it in chat.
Okay, figure 6 is the observed variation time in the interference patterns. Pattern in the interferometer dynamic operation regime. So what was that? How long it takes for it to settle after they turn it? Is that what they're...
I'm not sure. We'll have to wait till he describes it.
Oh, okay. All right, let's continue. So the difficulty is connected with the small values visual readout of the value d. slowly changing at the dynamic regime, and i.e. at t approaching TD. In the figure 6, the dependence view of d times t created the data visual observations shown. However, as it can be seen in figure 6 on the original site, by the extent about 1 second of the dependence time dt differed from the expected time course qualitatively after the device rotation in 180 degrees at the moment of time. At the moment of time t0, the band still occupied the initial position, i.e. d t sub 0 equals 0. Instead of the anticipated, according to equation 22, the figure for value of dt sub 0 equals max.
Dude, that's exactly what it is. You're spot on.
Nice.
That's pretty interesting, actually. They turn it, and that's what the fringe shift does.
Just does a little or whatever,
Yeah.
right? Nice.
Just a little,
Cool.
quick little sag neck.
A quick little saggy.
A quick little C's not constant for you.
All right. All right.
Quick little saggy. I got me take over.
Yeah, sure.
So there were
Is that how-
suppositions. What's that?
I forgot my mic has a button on top. I turned it off. Is this how this usually goes? You just read into your voice and you're like, okay, someone take over or I'm going to fucking die. Okay. So it seems like it'd be better with 3, huh? Or like anyone else? You guys just watching this torture with nothing? Or what's going on?
I mean, bro, you trying to read or like what's up?
People can fucking read, right? Everyone can read here. That's how we got here.
Popcorn Shane.
Dude, like, I tried this the first time. I got 3 pages before I was like, yeah, I'm gonna revise my strategy on this one because this got really boring. Really, like, I was just it was Gleason too, which is pivotal.
Can we do a recap real fast, where we keep going through like another big chunk of the ocean? You know what I'm saying?
That would be good too. Yeah.
What's the overall setup that he's taking all this data from? Like, what's the experimental setup? Radio emitters?
No, optical interferometer. Hold on, Toby's going to the diagram now. All right, so we have an optical interferometer set up here, and the way that it splits the light beam, it's such that one of the beams passes through the through a tube, so they have it contained and they have a gas in it, and they're gonna do some measurements with that, and then they have a beam that goes parallel to that that's exposed to like the free ether wind, right? So using this apparatus and configuration setup, when they turn the device perpendicular and also coinciding with the ether wind, they can they take fringe shift measurements based off of that, and then also corresponding to what happens with the gas inside of the tube, with the fringe readings that they get from that, they take like differentials off of that to get a kinematic viscosity of how the ether wind like passes through the metals, right? Because like he swaps out different shieldings, like different dielectric insulators and metals. So so basically how fast the ether can pass through that metal shielding and affect the gas inside. So like they're using laminar flow, and like when that flow becomes turbulent, that's when he determines that the ether wind has successfully kind of taken over that tube, so to speak, when they have it coinciding with the wind.
Okay.
All right, and then let's see. I think that pretty much sums it up. Does that sound about right?
I thought we were reading somewhere where it said like the one path was like roughly equivalent to the other one. So they're measuring the difference in the paths in terms of timing, like the fringe shift, and then deducing characteristics about the ether by changing variables in one arm of the path that has the tube with like shielding and stuff to get a different reading every time and comparing the different readings.
Mm-hmm. Yeah.
Okay.
Yes, sir. Yo, what up, Eric? Welcome.
Hey, Eric.
So they're able to measurably like change the fringe pattern in that one arm via how much metal or what kind of metal they put on the outside, what kind of dielectric they use.
Yep. And they also have thresholds set for like how long it takes for the interferometer to like reset after they rotate it. So they have like very specific parameters and time thresholds for when they're actually measuring the effect of the ether wind, and not just like some variation like when they moved it or something like that.
Oh, you're saying they're like changing the orientation, then they're waiting a minute before they start the experiment again?
Yeah, they have like a graph and shit for it. Like you can see like the swings for it and all that. So like all the motion that the interferometer experiences, they can like statistically deduce and rule out as like noise or whatever, So like they have a very specific parameter set where they can determine, when the ether has basically, enacted on that, right?
So it takes a second for it to start acting on the light inside. It's just not all the time.
So it's based on when the way that they're doing it. Well, yeah, because it has to go through the material, right? When it's when they align it to coincide with the wind, it's like how fast it passes through it, right? So when the gas inside of that goes from laminar to turbulent, that's when they start taking their readings.
What kind of does it give? What kind of order of time that we're talking for it to go from one to the other once they turn it in the direction?
Yeah, it's in the graphs.
Is it like seconds, milliseconds, microseconds? Like,
Milliseconds.
okay.
All right, yo, Toby. I think Toby DC'd.
Oh, I'm like something's pittering and petering here.
Sharing. Yeah, I got you. 1 second. Hold on. No worries. Let's see.
Oh, Alan, in those additional references from Galaev, we got some extra drawings, but did he ever provide a photograph of the interferometer that he was using?
It's a good question. I thought I saw one. I'll have to double back. I think I did see one, but it was like in a different book.
Is that a southern-facing gentleman?
Yes. I don't know where we left off at before we DC'd. We were on like page, or no, right around here actually. This isn't the right one. Is it? Yes, it is. All right. I think we were right around here. So
I can't see it.
yeah, I should probably share it, huh?
Only if you want people to see it.
only if the boys want to see it. All right. So here we are with the variation in time of the interference pattern offsets. All right. All right. So let's write down the expression for the value dt. For the purpose, we shall substitute the expression of equation 11 and in equation 34 and in 32 for the values wpt and wct. Accordingly, to allow proportional values of equation 31 and 35, we shall receive equation 40. In figure 7, the normalized view of the dependence calculation results of dt performed with the expression of equation 40 is given. At the calculations, the term number of the series k equals 4, the calculated value of the ether kinematic viscosity is v sub c equals 7 times 10 to the minus 5 meters squared per second squared negative. Eric, how do you read that? It's making me nauseous. It's making me upset.
Well, certainly you got 7 times 10 to the minus 5th meters squared per second.
All right, and then what do we got over here with your guy? -1.
Oh, that's the per second. Or meter squared over second.
Oh, is that meters per second or whatever? Is that one
Right.
of those?
The
Okay.
-1 is it's in the denominator. It's to the -1 power.
Gotcha. Okay, cool. Because he wrote meters per second earlier differently, so I didn't know if this was like a different thing. Okay.
It means divide by seconds.
Cool. So, and the following values of the interferometer design parameters are used for AP equals 0.0105 meters, alpha sub H equals 0.0367 meters, L sub P equals 0.48 meters, and lambda equals 6.5 times 10 to the minus 7 meters. And from figure 7, it follows that the time experiment T sub m is approximately equal to 0.82 seconds, which is digitized from the moment of T0 from the beginning time of the interferometer dynamic operating regime. The band offset maximum value of the interference pattern, value D, should be observed. The anticipated duration of the interferometer dynamic operating regime, dt, is approximately equal to 10.3 seconds. Let us use the expression 40. Let's see, expression 40 for specifying the observed values experimentally. Tm is approximately equal to 1 second. For this purpose, we shall substitute in equation 40 the measured value of the ether kinematic viscosity is equal to V sub ether equals 6.24 times 10 to the minus 5 meters per second seconds. Let's see, meters per second, which we shall receive Tm is approximately equal to 0.93 seconds. Hence, the calculation results do not contradict the experimental results which are shown in figure 6. The interferometer test results analysis, the ether kinematic viscosity values are calculated and measured, give a basis to consider that the ether stream properties are close to the stream properties of known gas at their interactions with solids to pass aside obstacles and go in directing systems. It can be suspected that the solids, i.e., dielectrics, metals, etc., at interaction with the ether stream render majority of the render major ether dynamic resistance. So, like I said earlier, when he changes different materials and whatnot, like there's different levels of impedance to that kinematic viscosity. So the amount of friend shift changes proportional to how fast it's able to influence that tube. It clarifies that the interferometer test results that the tube made of dielectrics can execute the same directing. Yo, Shane, your mic. Same directing system role for the ether as the tube made of metal. The ether stream property, i.e., to pass aside obstacles, could cause unsuccessful attempts to detect the ether when the device is placed in a metallic chamber. Citations 17 through 20, 23, and 23 through 26. For the value definition of the ether drift horizontal component velocity WH, it is possible to use the band offset measured value of the interference pattern at the moment of T sub m when T sub m is at max. From the expression 40, we shall receive equation 41. Let us substitute in equation 41 with the measured values of the ethered kinematic viscosity of V sub ethered equals 6.24 times 10 to the minus 5 meters per second, or meters squared per second. The value, the value Tm equals 1 second. The design parameter value of the interferometer and the calculation parameter, the terms numbers of a series AP equals 0.015 meters, alpha sub H equals 0.0367 meters, L sub P equals 0.48 meters, lambda equals 6.5 times 10 to the minus 7 meters, and K equals 4. In this case, the measured value of the ether horizontal component velocity will be defined as follows. WH equals approximately 525 D times sub D. Welcome back, Toby.
You guys' internet makes my soul frown.
Yeah, I don't know. All of a sudden, over the last couple days, Kind of weird.
Well, it's probably got nothing to do with the truth you're hosting over here and the stuff that's happening.
Yeah, it couldn't possibly be AT&T. So where were you? I thought I had found you, but then now I'm not so sure.
So if you type in parentheses 42, you will get you'll get where we're at.
Boom.
Nice.
So right here.
Yep.
Want me to take over?
If you want.
All right, let's calculate the minimal value of the ether drift velocity, WH-min, which can be measured with the manufactured interferometer, i.e., we shall determine the instrument sensitiveness. In the part, the interferometer test is marked that the minimum value d-min, which can be digitized with a selected I fragment and scale d-min equals to 0.05, then with the expression 42, we shall receive WH-min equals to 26.25 meters per second. Let's determine the ether stream regime in the interferometer tubes at WH equals WH-min. For this purpose, with the expression 4, we shall calculate the minimal value of Reynolds number, Reynolds minimum, or Reynolds min, for the tube with radius A sub P equals to 0.0105 meters, in which the ether with the viscosity VEA equals to 6.24 times 10 to the negative 5 meters squared per meter squared second 10 to the negative 1 moves. Let's receive Reynolds min is approximately 8834. According to the requirement of equation 3, it can be written down that Reynolds min is greater than Reynolds C. Hence, at the ether drift velocities WH greater than or equal to 26.25 meters per second, the ether stream turbulent regime is possible only in the interferometer tubes. The optical interferometer tests and test results analysis give the basis to consider that the hydrodynamic description of the interferometer operating principle reviewed above is adequate to the imaginations about viscous ether stream tubes, and the manufactured interferometer is suitable for the ether stream velocity and the ether kinematic viscosity measuring. The measuring methods. The interferometer was disposed in the country settlement at the height of approximately 100. Oh, there we go. Or that was the other. Never mind. We were talking about Kharkov earlier. The other one. I guess this is still probably Kharkov, right? Almost for sure.
Wasn't that
Oh,
high
there we
above
go.
sea level.
Right there.
So yeah. Yeah, there you go.
13 km from Kharkov.
Shout out to Kharkov.
13. Shout out to Kharkov. Have fun with the volcanoes. Northern suburb, approximate height of approximately 200 meters above sea level, is located westward apart 1.7 kilometers. 2 points were arranged for measurements. The distance between them was about 15 meters. On the point number 1, the interferometer was at the height of 1.6 meters above the ground surface. On the point number 2 was at the height 4.75 meters. 2 points available, which are located at different lengths, are practically the same point of terrain. It is required for the observation of the height effect. The measurements of the points number 1 and number 2 were performed in the open air. The point number 1, the interferometer was in the surrounding tree's shadow and was not exposed to direct solar radiation affecting within a light day. On the point number 2, the interferometer was mounted in an umbrella shadow. In wintertime, the interferometer was transferred to Kharkov. The point number 3, or approximately 30 meters above the ground surface, or around approximately 130 meters above sea level, was arranged in the upper level facility of a bricky house. On the point number 1, the measurements were carried out in August of 2001. On the point number 2, in August of September, October, and November of 2001. On the point number 3, in December 2001 and January 2002. The measurements were carried out cyclically. One measuring cycle lasted 25 to 26 hours. 2 to 4 cycles were performed within 1 month. Each cycle contained the following parameters. The interferometer was mounted on a selected point so that its rotating plane was horizontal. After installation, the interferometer was kept in new heating environment within 1 hour. The instrument was stored in the facility. The The measurements were carried out at each whole hour of stellar time. One readout of the stellar value was performed under the following schema. The interferometer longitudinal axis was mounted along a meridian so that its illuminator was turned to the north. The further procedures did not differ from the interferometer operating procedures which were applied at the final stage of the interferometer test. After the interferometer dynamic regime termination, the observer registered the maximal bands offset value d times Tm as the measured value. The band's release time to the original position was registered and metered. The interferometer returned to the steady operating regime. The instrument turned to the initial position. As a rule, 5 to 7 readouts were done during one measuring time of approximately 10 minutes. The readout mean value was accepted for the measured value of d times s, where s is the measuring stellar time. The processing methods of the measurement results. The measurement results processing included the following procedures. Values calculations of the ether drift horizontal component velocity WH, a daily course of the ether drift velocity. Let's go ahead and get some highlights here.
Although the emphasis in your voice is carrying it a really long way. The effort is going far, dude. For real.
Dude, we had to increase the passion level after you called us out,
Right?
bro. You came
Dude, like,
you came
honestly-
reading when I'm sick, bro. I'm like making it through, and you're like, "You guys
You
dead
were-
in here?"
You sounded like you wanted to die rather than finish that fucking sentence. You were like, Toby, did you want to read for me, please? I was like, oh shit. I'll read what's going on. Okay.
Is that what
Yeah,
it
dude,
sounded
that-
like?
Yes, exactly that. And now Toby's like jovial and like interested. Like clearly it's fake, but it's better than it was.
Hold on, I got you. Hold on, I got you. Where we at, Toby?
We're right here.
All right. The ether drift velocity daily course average during the year epoch WHS so the ether wind on sidereal time. The daily course of the ether drift velocity averaged for the whole time measurement series is WH in parentheses S. So WHS is ether wind sidereal time. The mean square value deflection of the ether wind from its mean value of, what is that? Dang it. I should have studied my flashcards. Anyway,
Letter.
yeah.
Language.
W.
Sigma.
There we go. Sigma W. The measurement results were introduced as the measured value tables DS, so D sidereal. So the values WH calculated with the expression 42 were brought to the same table for each hour of the stellar day for such number consequence obtained for separate stellar days described. A daily course of W is the ether wind on sidereal time. The mean values of the ether drift velocity and the values sigma W are calculated for each hour of the stellar day with the following known expression of equation 30. And there we have equation 43, which leads us into equation 44, where rho is the value of the ether wind obtained during the whole measurement series. So the summation of the sidereal fluctuations and all that, or against sidereal time, gives you the total value of the ether wind.
Right. Alan, that's the W's with the bar over it. That's the mean sidereal value. It's a weighted average it's an average. And the sigma W is actually the standard deviation.
Oh. So
Sigma was close.
So that bar on top, what was that again? That was the average of that?
Average or mean. Yeah, it's computing the average.
Okay.
And then, so he's basically just doing the statistical computations to give the average over the sidereal time and then the standard deviation for that value.
Nice.
That's awesome, actually.
Yeah, thank you, Eric. That's fantastic.
You're welcome.
You say I can't listen to these boys struggle. They're good-hearted, but man, are they making a fool of themselves? Hold
Dude.
on, I gotta open my mic.
Dude, he's a good man, and we thank him for it.
Right? Good-hearted.
The confidence intervals of the measured values were calculated with the known methods explained for the example in the work of citation 30. The calculations were performed to the estimation of the reliability equal to 0.95. So that was that threshold that they had determined when they would be good to go. And the measurement results, the measurement series results held since August 2001 till January 2002 are presented, and the work 2,322 readouts of the measured values have been performed during the series. The distribution of the readouts per month of the year is shown in Table 1. According to the research problems, we shall consider the work results along the experimental results of Miller from Michelson and at Cleveland and Miller at Mount Wilson. These 4 experiments have been performed at various points on the globe with three different measuring methods: the optical interferometer of the first order, European Ukraine 2001 to 2002. This work, the radio interferometer of the first order, the same thing in 1998 to 1999, done by the same gentleman. Optical interference of the second order, Northern USA. So this is Miller here. So 1925 to 26, and then 1929. The measuring method action were applied in the above mentioned experiments based on the wave propagation regularities and the moving media responsible for these wave propagations. What's all the moving around, Toby? Is there some significance to this experiment that we just read?
Yeah, well then I'm also just pumped because we have those other couple of new random old Galaev papers.
The old stuff. Let's see. So that allows.
Oh, here it is.
Ooh. Oh.
This is not necessarily, I think, what she's talking about here, or what he's talking about here. I mean, sorry.
Nice.
98 and 99.
How dare you misgender an ether speed researcher, man?
Dude,
well, some random translation called Galaev a she somewhere, and then I got curious, and then I went and found a picture of him.
And it was decisive.
Yeah, it's decidedly a dude.
With his pronouns.
Yeah.
So the development regularities of this is where we are, right?
Yeah.
I can take over. The development regularities of viscous medium streams, fluids, or gases in directing systems are used in the work measuring method. The measured value is proportional to a velocity differential of the ether viscous streams in 2 tubes of different section with the original hypothesis. This differential value is proportional to the ether stream velocity, the first order method. The experimental results measuring method of 1 through 3 of citations 1 through 3, the regularities of viscous medium streams near the surface partition are used. The measured value is proportional to a vertical velocity gradient in the ether stream near the Earth stream or near the Earth's surface within the original hypothesis. This gradient value is proportional to the ether drift velocity, the first order method. In the experiments of 7 through 9 and 10, Michelson's cruciform interferometers were applied. The measured value is proportional to a velocity differential of wave propagation in orthogonal related directions in the ether drift stream within the original hypothesis. This differential value is proportional to the ether drift velocity, the second order method. In the figure 8, the experimental results referring to August are presented. On fragments of this figure are shown accordingly in figure 8A, this work's results. In the figure 8B, the experiment results. The figure is published for the first time. In figure 8C, the experiment results of citations 7 through 9. The ether drift velocities WH in kilometers per second are pending on ordinate axis. The stellar time S in hours is pending on abscissa axis. Each of figure 8 fragments illustrate the variations of the ether drift velocity within a stellar day, WH times S. So figure 8 fragments. Figure 8's table 1.
Did you guys note that the people who did this called it ether drift from way back when? That's not a cool colloquialism invented by Alan, even though it sounds just like it. Because someone was like, "What about that ether drift?" I'm like, "Well, we don't call it that. That's what the G's who discovered it called it." But whatever.
Yep.
It's all over the paper.
What Miller? Here's Miller, man.
Yep. That was the first
1930.
time I saw it. Right, I was like, "Oh, that's a nice sounding phrase to describe what it is." But all the people use the same like terminology when they were describing. All the papers read that way, right?
Everyone called it that, yeah.
Right. It's like globularists. They all knew the lingo.
Yeah. Oops. All right. So, figure 8, variation of ether drift velocity within a day in August. There you go. There's a space effect.
Indubitably. So, a translation of motion that matches sidereal time, where the fluctuations reach their minimum and maximum dimensions corresponding to sidereal time. Sorry.
Crazy.
Yeah.
It's actually absolutely crazy. Couldn't possibly be an ether wind.
It's such the well researched, like detailed, explored. Like it's so nice to find all this wonderful work already done.
I don't know. Definitely looks like Earth rotation to me.
Like imagine if we had
Dude.
to go do all this, dude, to prove the Earth didn't spin.
Dude,
Don't you guys feel when the Earth speeds up like that at about 4 a.m. every day?
You know when the sun rises and the Earth speeds up faster? Wait, what?
Dude, we rotate into it or whatever, right? Or,
Well, I thought,
we gotta
rotate backwards
Shane, we have
faster than the speed of sound. If you did that, you'd never catch it, dude. You'd purposely chase the sun around the
Dude.
sun.
Oh my god. That's crazy.
Notably, the same thing Maurice Elias found with his pendulum. This looks
Yep.
so familiar.
Yeah, I can't believe that their method was, I don't know, just ignore it, don't answer any questions, and don't tell anyone about it. Maybe it'll go away.
All right, so where were we?
Well, you know, if they're getting away with just having the pilots assume that the Earth is stationary when they're trying to land, and that it can't be stationary and moving, right? They can't assume that it's stationary if it's actually moving. So they're getting away with that. Like, of course, the ether wind is going to be nothing to avoid.
All right, let's knock this out.
They got guys saying that it'd be just the same.
Yeah.
If it was spinning as if it were. Come on.
Right. Nah,
Right.
you're good. We're about to knock this out though and dip.
Each of figure 8 fragments illustrate the variation of the ether drift velocity within a stellar day, WHS. The experiment results are presented only by the authors of work of citation 10 as ascertaining of the velocity maximal value measured by them in relation to the movement of W approximately equal to 6 kilometers per second. That is not allowed to show this experiment results in the figure 8 as the daily dependence WH of sidereal time in the figure 8. The measurement data averaging results were presented with the thick lines, which are obtained in each of the experiments during the August epoch, meaning mean results. The separate observations measurement results during a separate day are shown within the lines. The dates of separate observations are specified on fragments. The separate observations on fragments of Figure 8A, Figure 8B are selected from the performings, which had the date proximate to the date of separate observation of Figure 8C. Fragment in which during the day had no skips during the measuring. The date discrepancy is stipulated also by the fact that the systematic measurements in the work began on August 14th of 2001 and in the experiment of 1 through 3 on August 11th of 1998. Okay, so 1, 3. Nine. Okay, so 8, 9, 1, 3. And these are both 1, 3. A and B and C. Crazy. Different experiments, same sidereal time fluctuations during August.
But dude, it was probably the temperature. Fucking.
That's so cool, man. The positive measure. What's that?
The real people back then who was following this were like, "Oh, it's a good thing they're gonna figure it out." And they're like, "Oh no, it's temperature. It was temperature, honey. No, none of it counted. Yeah, all 5 million. Yep, all. Yep, doesn't matter. Okay,
Now put it in metal and
You know what I
measure it
mean?
again.
Like, what the fuck?
Put it in a metal shielding and measure it again.
Put it invert. Turn it upside down. Can you put it underground? How about you drape it in a sheet? Is that all right?
The positive measurement results given in Figure 8 illustrate the development of the anisotropy effect, or the anisotropy effect, the ether drift required effect. In the work and in the experiments 7 through 9 and 10, the anisotropy effect was discovered by the optical interferometer rotation. In the experiment of 1 through 3, the opposing radio waves propagation was applied. The similar nature of the ether drift velocity variation within a day in August epoch unite all 3 fragments of the Figure 8. The first minimums in dependencies, WH is what again?
WH is the ether wind,
Ether wind,
just the
thank
natural
you.
ether wind. Yep.
So the ether wind according to sidereal time are expressed clearly in all 3 mean results. In the work of Figure 8A and in the experiments of 1 through 3, Figure 8B, temporary position of minimums is sidereal is approximately 3 hours. In the experiment 7 through 9, Figure 8C, the temporary position of the first minimum is sidereal is approximate to 0.8 hours. Such discrepancy in the position of these minimums is about 2.2 hours. An explanation has not found yet. The ether drift velocity wait, what? So there's some discrepancies. That's interesting. Okay. Guess you can kind of see it there. Yeah. Huh.
I mean, they're like the most sensitive instruments that
Yeah.
we know of, that I'm aware of. Like, I don't know. Seems like if
But
the
then
wind farted,
also it could just be related to the greater cycles, right?
the greater maximum, meaning the electromagnetic ionized field that it's measuring is so excited that it
Yeah.
measures erroneously, goes too
That's,
far one way.
well, I think it's real. I think it's relative to the cosmos as a whole. So if we're not on the same part of like the Apparel cycle or whatever, then it's not gonna
I
be
thought that was
exactly
if
the
you
same.
detected orbital velocity. That whole like solar system stuff is dependent on a bunch of other stuff that never got.
Hey, Eric, you know what wavelength this laser was?
For this experiment, no. On the other one, I know what. Well, it was they didn't use lasers. That was radio waves. But no, I haven't been looking. I haven't looked at this paper as in much detail as the other one.
Okay. Yeah, I thought we read over the wavelength at the beginning, but can't find it. Anyway,
So the ether drift velocity magnification is observed during the consequent 2 to 3 hours. Further, the plateau sites with rather small variations of the ether drift velocity and time are noticed on all fragments. The greatest duration of the plateau site was observed in the experiment of 1 through 3, figure 8b. That can be explained by arranging peculiarities of a radio frequency spectral line on terrain. In this experiment, the radio frequency spectral line is declined from a meridian on 45 degrees to northeast. The variations of ether drift apex azimuth, as well as any star azimuth, occur symmetrically to a meridian line within a stellar day. If to take the apex coordinate values into account, according to Miller, let me pull my thing up.
Delta.
Delta is approximately 65 degrees. Alpha is approximately 17.5 hours. The ether drift azimuth in this part of a stellar day accepts the values which lay in the northeast direction, i.e., the direction close to the direction of a radio frequency spectral line. In this case, the angle between the ether drift azimuth and radio frequency spectral line direction has minimum values. Accordingly, at the interval of 12 to 16 hours, the ether drift radial component velocity directed along a radio frequency spectral line keeps rather high value despite of the apex height magnification astronomical coordinate. Such arranging peculiarities of the radio interferometer on terrain can explain the relative dependence variance ether drift of sidereal time at the interval of 12 to 16 hours in comparison with the same of figure 8a. According to the accepted measurement methods, the optical interferometer was located along a meridian. As the variations of the ether drift azimuth within one stellar day occur symmetrically to the meridian line, in this case, the plateau site duration should be less than in the experiment of 1 through 3, and less than the experiment of 1 through 8, so 7 through 9, in which the ether drift azimuth variation was considered by the corresponding rotation of the interferometer. It can be seen in figure 8a, the mean result of the work, that the sites with rather small values of the ether drift velocity extended in time take place within a day. Noticeable bands offset of an interference pattern was not observed per a separate day on such sites. In these cases, the ether drift velocity was lower than the interferometer sensitiveness, i.e., the ether drift was less than 26 meters per second, that was used for the interferometer test, the purpose of which is given in the above mentioned part, the interferometer test. Systematic character of experimental investigations of this work and the works of 1 through 3 and 7 through 9 has shown that dependencies measured in one and the same epoch of the year of the ether wind sidereal time have the similar character of the ether drift velocity variation within a day. At the same time, dependencies viewed of the ether drift velocity with sidereal time, the ether drift with sidereal time measured in different epochs of the year differ from each other. That can be noticed, for example, by the experiment published results of 7 through 9. The reasons of such seasonal variations has not been defined yet.
What could it be? Because, dude, it's just the Earth rotating faster, Toby. It's just sometimes you just gotta speed up and slow down, bro.
Oh, you know what it is? The Earth has its own retrograde, and that we just can't see it when we're on it because of reference frames. So, yeah,
that's a new one,
right?
I don't disagree with that. Sorry.
It can be suspected that. Oh, go ahead.
Yeah, sorry. Just wanted to let you know you guys are doing great. I'm gonna take off, but keep on going, guys.
Peace, bro.
Yeah. Thanks for the good words, kind words. We will keep going. It can be suspected that magnetosphere at its considerable sizes and peculiar shape, ionosphere, the known variations of their state can be responsible for such dependence. You're talking about those spheres, those concentric circles of ether wind.
Where's that?
relating to the sidereal time right here in the magnetosphere. It's like, yo, right after he talked about how it has not been defined yet. Yeah. Yeah, you might be talking about some
Hang on, sorry.
big
Okay.
physics questions.
It can be suspected that the magnetosphere, at its considerable size, is in peculiar shape ionosphere, that the variations of this state can be responsible for such dependence variations of the ether wind and sidereal time. So he's saying the ionosphere and the magnetosphere might be deflecting the ether wind in some degree. Is that what they're saying? Is my mic on?
Yeah, I think you're right.
Okay. Okay. Yeah.
Pretty interesting.
Yeah. It's that pear-shaped magnetic field, man. It's interfering with that ionosphere.
So it can be seen in the figure 8. The ether drift velocities measured in each of the experiments differ. That can be stipulated by the arranging height differences of measuring systems above the Earth's surface. 1.6 meters, 42 meters, and 1830 meters. The collection of such data illustrates the height effect development. In the work, the ether drift velocity measuring have been performed at the heights of 1.6, 4.75 for the height dependence discovery. In the table 2, the mean variable or the mean values of the ether drift maximal velocity are given, which are measured in the work in the experiments of 1, 3, 7, 8, and 10. In these four experiments, the measurements are performed at 5 different heights: 1.6 meters, 4.75 meters in the work, 42 meters in the experiment, 265 meters, and 1830 meters. Cleveland and the observatory Mount Wilson accordingly. In the experiment, the measurements were carried out also in the observatory of Mount Wilson. However, in contrast with the experiments of 7 through 9, which was carried out in the light wooden house, experiment 10 is performed in a fundamental building of an optical workshop of the observatory. It can be supposed that the ether stream breaking by the house walls was the reason of the ether drift velocity smaller value measured in the experiment 10 in comparison with the experiment result of 7 through 9. The table 2 gives the imagination about the ether drift velocity variation in height band above the Earth's surface from 1.6 meters up to 1830 meters. Ooh, this is interesting. Okay. In the figure 9, this dependence view is presented in the logarithmic scale. Whoops. Whoa, whoops. Come on now. What?
Highlighter broken?
I don't know. I guess so, man. There we go. On the abscissa, the ordinate axis logarithmic values W over W star and Z over Z star were pending accordingly, where W is the ether drift velocity at the height of Z. The values W star and Z star are considered equal to 1 meter per second and 1 meter accordingly. Okay, so where is this whole figure 9? So it looks like, he's trying to take into account viscosity on Mount Wilson walls.
Yeah, he's trying to derive like a gradient across the globe, right? That global gradient.
So meters per second, 10,000. It's not that different. Is it? I can't recall. That's pretty much the same. Or no, he had 8,000 before. He bumped it up by 2,000, right?
Yeah, see that's the thing when you when you go over.
Well, because
yeah,
he's accounting for the walls now.
Oh, is that?
Yeah, that's what he's saying here. In contrast, it was carried out in a light wooden house performed in a fundamental building of an optical workshop. It can be supposed that the breaking by the house walls was the reason. And so table 2 gives the imagination about the ether stream variation. Actually, I don't know. So this is table 2. What's figure 9? Wait, we didn't look at figure 9. Depends on the ether drift velocity on the height above the Earth's surface. Is this work experiments? That's the. Oh, so yeah, this says meters per second. Or kilometers per second, rather. And then kilometers. There you go.
No, altitude in kilometers. Right?
What did I say?
The same thing twice.
Oh.
What did I say? Just fucking, you made a sound with your mouth. I don't know.
Yeah, altitude. Yeah, Z over Z is altitude, and then the
That's what I meant. Yeah.
other one is the speed.
bad.
That's awesome.
You're good.
Cool.
So yeah, there's
Well,
a
yeah,
linear. So does that look like a linear relationship,
linear-
dude? A linear
to the height.
graph.
A linear deviation depending on the height relative to the height. The further up you go, the faster it gets, or what?
Yes.
would
directly
be-
relational to an orbital
Oh,
component.
It's weird
two.
when they keep lining up exactly like how we need, right? Feel bad for
I
them.
mean, it's dope for us, right? But like not
right.
so
I mean,
good.
it's really it's really useful when everything keeps lining up. Like you barely even have to do anything.
Has to
Alright.
line up. Well, basically.
Direct relationship to the translation of the motion of the sky.
Exactly.
Or else they'd have a stencil or an arc. You know.
I wonder why they hit all this, dude. And like, I wonder why Dayton Miller died a quiet death, and then he was awful, and nothing mattered. And they brought out all the new stuff.
So we are here. It can be seen from figure 9 that the different experiment results are near one straight line, and in height band from 1.6 meters up to 1830 meters, the ether drift velocity increases with the height grown above the Earth's surface. The boundary layer has considerable thickness that can be the consequence of the ether stream and the atmospheric interaction. Boom, highlight. These data do not contradict the imaginations of the Model 4 through 6 about the viscous ether and its stream near the Earth's surface. From Table 2, Figure 8a, and Figure 9, it can be seen that the ether drift velocity is rather small near the Earth's surface. That can explain the reason of zero results of many experimental works, in which the value of 30 kilometers per second was taken as the ether drift anticipated velocity. In such experiments, the metering device sensitiveness was obviously poor. With the expression, it can be calculated that the ether drift velocity of 200 to 400 meters per second, the methods of the second order almost are inapplicable for measurements. Real quick. With the expression 1, it can be calculated at the ether drift as in the case such measurement sensitiveness, the ether drift velocity is low in 6 orders than the sensitiveness of the first order methods. The ether kinematic viscosity has been measured in the work. The measurement results are explained above in the part result analysis of the interferometer tests. That is stipulated by the peculiarities of the experiment implementation. The measured values of the ether kinematic viscosity are in the limits. VEA is approximately 5.5, iterating up to 7.1 times 10 to the negative 5 meters squared per second to the negative 1. The mean value is equal, VEA equals to 6.24 times 10 to the negative 5 meters squared per second to the negative 1, that according to the value coincides with the ether kinematic viscosity value calculated above. VC is greater than or equal to 7.06 times 10 to the negative 5 meters squared per second to the negative 1. Hence, the differences between the dependencies ether wind of sidereal time and the ether drift velocity measured values available can be explained by the measurement method differences of the work and the experience of 1 through 3, 7 through 9, and 10, and differences between arranging heights of measuring systems. The results of 4 experiments do not contradict each other that illustrate the reproduced measurement nature of the ether drift effects in various experiments performed in different geographical conditions with different measurement methods applying.
So
Boom.
Miller reproduced with different apparatuses, different locations, different materials, etc., yet the fluctuations are measured the same when you plot them against sidereal time.
The mean
But,
daily course of
dude.
the ether drift velocity.
Nice.
Oh, nice.
Temperature, though, you guys didn't account for temperature clearly. So, do another 5 million. That's obviously what's causing the deviation exactly in line with the sun each time. So,
Like the periodicity that just happens to match up every day is just totally random. Trust us, it's just
and
temp.
consistently random. Yeah, like into the what 7 order of million 100,000 times to the odds. It's definitely not the ether drift, that's for sure.
According to the original hypothesis, the ether drift velocity horizontal component, ether wind, should change its value with the period per one stellar day. The space effect. Make this blue. For revealing the ether drift velocity component with such period, the results of systematic measurements were subjected to statistical processing in stellar timescale. The results of such processing are shown on the figure 10. On the fragments of figure 10, the stellar time, sidereal time in hours, is suspended on the abscissa axis. The ether drift velocity value, ether wind in kilometers per second, is suspended on the ordinate axis. The vertical hatches indicate the confidence intervals. In the figure 10a, the mean daily course of the ether drift velocity within a stellar day, ether wind sidereal time, is given. This dependence is calculated according to the measurement results of the work which were performed during the 5 months of the year since September 2001 till January 2002. During 5 months, the numerical value of stellar time shifts regarding the solar time is in 10 hours, or regarding to the solar time in 10 hours. Then September till November, the measurements were performed on the point number 2 in December and January on the point number 3. The mean values are calculated with the expression 43. For comparison, in the figure 10b, the mean result is given, which was obtained in the experiment 1 through 3 during the year's 5 months of the same name since September 1998 till January 1999, here as contrasted to the similar figure given in the works of 1 through 3. The measured value is expressed in the ether drift velocity values. Yo, what are these, man?
What are these? The equinoxes.
No, but 98 and 99.
Oh, that was when he did his measurements.
The ones from the 2001 paper, is that right?
I think so. Or no, he did.
Okay.
Well, his 2001 paper was about his 1999 and 1998 measurements. So.
Oh, so 1 and 2. Dude,
Oh, yeah.
We need 1 and 2.
No, we have those. Right? We're reading.
We have 3. Whoops.
Oh.
We have 3, I think. He probably talks about this in that book, right? About both of these?
Yes. Because it's like a summation of both of them. And I only read like halfway through the review of this one that we're reading now.
Experiment in the band of radio wave, ether drift effects and experiments in radio waves propagation, ethereal wind and experience of millimetric radio waves propagation. Come on, come up with some. Because then they get translated and it's like I can't tell which one's which.
I don't know how many synonyms are in this fucking sentence.
Yeah. So yeah, I think it would be nice to get those original papers.
Well, the people that usually provide when the community doesn't have them is you guys. So I mean, we can hope for the best, or
We've been trying.
Yeah. So
we found some other more recent stuff that was pretty interesting. So.
Do you remember when we weren't sure about Etherwind, and now we have like an overabundance of fucking already previously done, reprised, highlighted experiments? It's like, oh, we couldn't find enough evidence for the ether, so
And now we can't stop finding it.
Yep, it's true. Here, as contrasted in the similar figure given in the works of 1 through 3, the measured value is expressed in the ether drift velocity values. In the works of 7 through 9 and 10, such data miss owing to smaller uncoverage of the year's epochs of the measurement statistics in these experiments. Both fragments of the figure 10 as a whole have similar nature to the ether drift velocity variation within a day. The differences in the curve shapes can be explained by viscous ether stream interaction with the terrain relief elements, which in these different experiments had the distinguished performances and features of the radio frequency spectral line arranging on terrain in the experiment. On the fragment of the figure 10A, this work, as contrasted to the result of experiment 1 through 3, figure 10B, the ether drift velocities have similar values that can be explained by the height distinction of measuring points in these experiments. The dependencies of the ether drift on the sidereal time have forms of periodically changed values with the periods equal to a stellar day that can be explained by a space galactic origin of the ether drift. Boom. Boom.
Yeah. The dependencies of the average speed of the ether wind when plotted against sidereal time have the forms of periodically changed values with the periods equal to the stellar day. Yeah.
That's a lot of words for saying they matched exactly. It's like, who the fuck are you talking to, guys? Anyway, like,
word salad.
Like you're talking to your buddy. Like, dude, if I use a lot of big words, I'm gonna impress Ted. Like, you know what I mean?
Like, Shane, tell me more about these dependencies.
Right? Like, if I
with.
could pump in as many descriptive words to impress Alan, I'm like, wait, what am I doing?
You want to take over, Alan?
Yeah, I got you, Brody. All right. So in the work, the observed band's offset direction of the interference pattern corresponded to the ether drift northern direction at the measurement implementation. Hence, the results of the work do not contradict the experiments of 1 through 3, 7 through 9, 10, and the imaginations of the work of 4 through 6 about the northern position of the ether drift apex that demonstrates the reproduced results of a nature or reproduced results nature of. Am I reading that wrong? Demonstrates the reproduced result nature of the ether. I don't know. The ether drift effect of the measurement and the different experiments performed with different measuring methods and application. So again, reproduced under different circumstances and different apparatus.
Yeah.
All right. In the work, we shall be confined to the qualitative comparison of the work results of the experimental data of 1 through 3, 7 through 9, and 10. For conducting a quantitative comparison analysis, it is necessary to specify the ether drift apex coordinate values on the celestial sphere. For the first time, we determined in the experiment 7 through 9 to specify an analytical view of the ether drift velocity dependence on the height above the Earth's surface proposed in works 1 through 3 to elaborate the calculation method of the terrain relief influence on the ether streams reforming near Earth's surface to determine probable influencing of the Earth's magnetosphere and the ionosphere that is subject to separate investigations and goes out of the frame of work problems. Due to this reason, the experiment results, the experiments of 1 through 3 and the experiments of 7 through 9 are given without any corrections, though its usefulness at the result comparison of the different experiments is quite obvious. Thus, in the work, the hypothesis experimental verification about the ether existence in nature, i.e., material medium responsible for electromagnetic propagation in optical wavebands, has been performed. Dude, I was thinking the same thing. I was like, how can I get another joke in there about that? And I'm glad you said that.
Said it so many times in this paper.
I was about to say, hey Toby, what's that medium responsible for the electromagnetic propagation of waves in the optical wavebands?
Material medium?
Yeah. That viscosity one that was measured down to the millimeter accuracy with radio wavebands.
Viscosity one? You mean viscous?
Yes, the viscous one. Yes, that one, the one that Shane said. All right, let's see here.
This is the viscous one. Yeah.
Yes. Let's see. All right, so the medium which is responsible for waves to propagate in the optical waveband has been performed. The estimation of the ether kinematic viscosity value has been performed. The first order optical method for the ether drift velocity and the ether kinematic viscosity measuring has been proposed and realized. The method action is based on the development regularities of viscous liquid or gas streams in the directing systems. The significant measurement results have been obtained statistically. The development of the ether drift required effects have been shown. Yeah, can you highlight that one too? The development of the ether drift requirement effects. Because remember, there was like a whole, there was like 4 criteria or whatever that he laid out. So the measured value of the ether kinematic viscosity on the value order has coincided with its calculated value. So wait, Toby, are you saying if you have a prediction and you like do an experiment, you measure it, like that your prediction was confirmed or whatever?
Earth ball go spin.
Mm.
I think pretty sure this guy's wrong.
Okay.
This is no peer review.
Oh yeah, that makes sense.
Stop talking about methodology and results.
Oh yeah.
Let's just
Dude, this dude measured something that was falsified in 1887 by Michelson Morley. What a nerd. The velocity of the optical wave propagation depends on the radiation direction and increases with height growth above the Earth's surface. The velocity of the optical propagation changes its value with the period of one stellar day. The detected effects can be explained by the following. 1. The optical propagation medium available regarding the Earth's movement. 2. Optical wave propagation medium has the viscosity, i.e., the feature properties of material medium composed of separate particles. 3. The medium stream of optical wave propagation has got a space galactic origin. The work results comparison to the experimental results executed earlier in the order of the hypothesis. Verification about the existence of such a material medium as the ether in nature has been performed. The comparison results have been shown. The reproduced nature of the ether drift effect measurements in various experiments performed in different geographic requirements. What different measurement methods, applications, whatever. The work results can be considered as experimental hypothesis confirmation about the ether's existence in nature, i.e., material medium responsible for electromagnetic. Yeah, dude. By the time we're done, we're dead.
we did it.
We did it. Ladies
How
and
long did that
ladies
take?
and gentlemen, we did it. Or whatever.
Everyone's asleep.
LIGO. Yeah. Yeah, don't worry.
It only took us
And that was a quick
3 or 4 hours.
2-3
Yeah.
hours. Not bad.
Dude, I
That's
knew.
not nearly as long as the last paper. We spent a lot more time going over things last time, I think.
Yeah.
But with this time, we knew what we were in for.
Yeah, I could tell you were taking your time when you were fucking strawing out the words to torture yourself for fun or something. When you were like, I don't. No, I'm just kidding. Dude, like, what do I knew that Lindsay wasn't gonna finish in time to be able to take part in this, but this is the second night that you decided to get together and read PDFs aloud to each other.
Yeah.
I'm joking,
Yep,
but
and anyone willing to listen.
Dude, honestly, we should do that every week because to listen to people read that can't fucking pronounce words and stumble is embarrassing to everyone. So we should all be able to fucking publicly reread. And the only way you get it is if you fucking read a lot and practice and, like, say it to your friends and try different tones and, fucking play with it.
Yep.
Otherwise, you'll
Learn
just
every
be
time
like
we
dry
read.
riff and not know how to read, and you'll be so fucking embarrassed.
And then Eric pops in the background and explains the math to us, and it's
Right.
awesome.
Right.
Dude, it all works out. You just trust fall into Eric and he'll just read he'll just read the equations to you.
Who did you trust fall that was a bungee jump the other day?
Oh, dude, dude, I trust fell into Toby and he was AFK. I was like,
Yeah,
I was like, Toby,
you here?
Yeah.
Okay,
Yeah.
good. I'm like, did you hear a yes? Or I don't think he's no. Go ahead. It's
Well, hey,
fine.
I'm gonna wrap up the
Yeah.
reading stream.
Sorry.
Oh, you're good. Thanks everyone
I'm
for
here.
tuning in and listening to the Galaev paper. Just to be clear, in case you just tuned in, I'm gonna have to patch some stuff together. But this was The measuring of ether drift velocity and kinematic ether viscosity within optical waves band by Galaev from the Institute in Radiophysics and Electronics of the NSA in Ukraine. Received on November 15th,
Fucking what a
2002. Again, thank you, and stay ethery out there.
Etheric.
Well,
Guys, this is
well
not-
said.
This is not hard.
No, I like stay ethery, man. Hey, stay ethery out there, guys.
I want to be ethery.
Can I have a viscosity viscous? What? I love that.
All right, there we go.
Yeah, I'm gonna wrap mine up too. All right, thanks for coming out, guys. Peace.